Testing. Can everyone hear me now? Can you hear me now? I think that one of my microphones is not working properly, but I just switched to one of the other ones and that's working fine. Oh, I'm getting heaps of people saying hi in chat. That is really good. Thank you for coming along, everyone. Um, Welcome to COMP1511, also known as Programming Fundamentals. I like to think of it not just as programming fundamentals, but an introduction to what computer science is. So over the next, I was going to say 10 weeks, but we're going to be together for a little over 10 weeks because there's still an exam afterwards. So let's say over the next 12 weeks, we're going to go on a little journey together into the world of computer science. We're going to be learning our first. Sorry, I haven't really spoken at all yet today, so. Not yet in the flow of lecturing. I've had a couple of weeks of not talking to, not delivering content to people like this. So anyway, over the next 12 weeks, we're going to go through and we're going to learn a whole lot about what it means to work with computers at a much deeper level than we may have up until now. So a lot of the things you may have done up until now with computers may have been just sort of using them as devices. I mean, some people I'm sure have done a bit of programming before, but what we're going to do by the end of this course is get us all to the point where we're happy with how we can get computers to do the things we want them to do, solve problems using our computers, get our computers to solve problems that us and the computers have never seen before. So it's a really interesting field. But let me start. I'm just going to go through the slides. I'm going to talk about a few things. First thing is definitely going to be, what are we going to talk about today? So we're going to be talking about a lot of stuff through the whole course, and we're going to structure it in such a way that we sort of build up the content bit by bit. So today, we'll start off with introductions. Just looking at chat. Yes, hello everyone. Oh, actually, just while I'm starting and speaking, everyone say hi in chat. I think it's great to just sort of get involved. We are in a new world now, where we won't be meeting in person. A small number of you, wow, look at the chat go! That's cool. A small number of you will be meeting your tutors, some of your tutors in person, because UNSW is slowly opening back up. We're still under some restrictions, under some COVID-based social distancing restrictions, so we can't fill up the labs, we can't fill up the tutor rooms, and we're definitely not going to make face-to-face teaching compulsory, so we're not forcing everyone to have like long commutes on public transport around other people, nothing like that, right? But there are some optional face-to-face tutorials. The survey went out for them last week, but I know that some people enrolled after that. The most recent course notice I sent out has some information if you want to sign up on the waiting list to try to get into those tutorials. So do that if you wish. And hello everyone who just said hi in chat. Thank you for coming along. So today, what we're going to talk about, we've got a 2-hour lecture. I'm going to have a break in the middle. I will nearly always have a break in the middle of lectures. So in the beginning, simple introductions. I'm going to talk about what it means to study at UNSW and do programming. It's pitched a little bit at people who have not done much study before. I'm not sure how many of you have been at UNSW the whole year or have just started at UNSW. So I'm going to pitch it as if you haven't really studied anything at UNSW yet. So I will talk a little bit about what it means to study like that. We're going to talk about how COMP1511 works as well, which means I'm going to be talking about what we're teaching, a brief summary and overview of what the content is in the course and what the parts of the course are. So I'm not going to go in great detail. If you want great detail, the course outline is available. It's on the course website. There's going to be links to the course website here in my slides as well. We'll get to that. Yeah. And also just talk about learning. Talk about how you can approach this course to get the best out of it. The second hour, we're going to start launching into content itself. So we're going to look at what computers are. And I know that's a funny thing to say because what computers are is like most of you right now are physically sitting in front of a computer. So you're kind of like, I know what a computer is, it's this thing. But we're going to talk a little bit about what the internals of a computer is and what the internals of a computer are. And how we approach that as programmers. If we're going to want to get under the hood and start getting computers to work with us specifically on things, then how would we approach that? It's a little bit different from just saying, okay, you just open up some other program and run it. Like you open up your Google Chrome and then you type things in and stuff magically happens. Someone built that, right? And what we're going to do is work towards being the people who can build things like that. So we're people who can say, I am able to get a computer to run things that I've created, not just run things that other people have created, and then learning about how to create those things. So we're going to get our first look at the programming language we're going to be using. It's called C. C is a language that's been around for, I want to say, at least 40 years. I don't think it's been around for 50 years, but I think it's been around for about 40 years. And it's one of the programming languages that one could say that nearly, I would say the majority of existing programming languages are in some way based on C, or at least deeply influenced by it, which is why we like it as a good starting language. It's also something that allows us to get really deep into what a computer does. So if anyone who's done some programming before is probably going to notice some interesting things as we get deeper into the course that you most likely have not done in any other programming languages. So we're going to get really close and personal with our computer. We're also going to be talking about Linux. Oh, I should not hover that part of the slide because the little pop-up window. Yeah. So Linux is an operating system. I'll tell you a little bit about what operating systems are in a second. And it's one of the things that we use a lot in industry. So we're going to talk about how to use a slightly different operating system on a computer than the ones we're used to. But I'll get into all of that later when we go into the details. Okay, first introductions. That's awkward. Let me just. I find this deeply ironic that I'm moving my face so that I'm not covering up my face. I could do this and it would have the same effect. But I'll put my face down here for the moment when I'm talking about this slide. My name is Mark Chi. I am your lecturer for this course, officially also course convener. I mean, most of the time when you have a lecturer, they're also the course convener because it's the person that runs the course. If you need to contact me, we have this email address. This doesn't just email me, but it also emails Tom. You may notice there is a name in the chat there, Tom Kuntz, who is the blue name with the spanner in the chat, and Tom is the subject admin, so he's in this list. There are too many tutors and admins to list right now. There's a team of about 20 people there. These are the people who you're probably going to have a closer contact with than me. You'll spend 4 hours a week with me in two 2-hour lecture blocks. Your tutors you'll spend time with about 3 hours a week in your tutorial and laboratory blocks, but you will be in groups with them that are much smaller. So you're going to get together with them and really kind of get to know them in a way that you won't necessarily have that kind of connection with me. So with me, it's like a 1 to 500 connection. You and your tutors, it's a 1 to 20 or so, or 1 to 20 or 30 or so, depending on which tutes you're in. So hopefully you'll get to meet them in person. There is a chance, I'm not sure if everything has happened with the emails yet, but there's a chance that the tutors have already emailed you. So you will already have some contact details for them, and they will already have given you some instructions on how to connect to your first tutorial. But we'll talk about tutorials in a second anyway. The course webpage here, this is the center point for all kind of information in the course. Nearly everything that we're going to tell you that is information that you need for the course is going to be on that page somewhere or linked from that page somewhere. So, for example, we have up and running already a course forum. The link to the course forum is on the webpage. Every email notice that I've sent out to the entire class is also on the homepage of the course webpage. So if you've only just enrolled, or even if you haven't enrolled yet in the course and you're still trying to finalize enrollment, you can still go to the course webpage and you can see every email I've sent to everyone who's enrolled. So a lot of the stuff on the course webpage is publicly available, like the current lecture slides, tutorial questions and things like that. So you can see that even if you're not logged in to our system web CMS there. It's probably better while you're starting the course to always be logged in though, because there's some stuff that we're going to have as publicly available, other stuff that we're going to have which is only available to current logged in students. So that'll be things like tutorial and laboratory solutions and things like that. So we're not going to give solutions out to the public. We're happy for them to see the questions if they want to. Yes, so the course forum, you should already have received an email sent from the course forum. If you haven't, you can always go to the course forum link and it might just connect you to the course forum immediately. If not, obviously there is this email address here if you need to get in contact with us, ask us questions about how to get things set up and things like that. In general, the way that we're going to run this is any administrative issues, you can email this email address. Any academic issues, like you're asking questions about the content and things like that, your tutor is the best person to talk to about that stuff. All right. So, move my face back out of the way. Welcome to programming, and welcome to UNSW. So I don't know how many people are just getting to UNSW now, or how many people have been here for at least 6 months already, and you know everything there is to know about UNSW, apart from what it's like to be there physically. And I apologize. I know it's not really, wasn't my choice for us to go into a global pandemic, but I still apologize that you haven't necessarily gotten the experience that you could have gotten at UNSW this year. But we're hoping that things will ease up a little bit. And for those of you who are in Sydney or in Australia, we may start being able to get to campus at UNSW. For those of you who are overseas and were looking forward to visiting Australia for your study, I hope that eventually we will allow our international students to come to Australia. But I mean, the whole pandemic situation is difficult, right? So there's not much we can do about that. But what I wanted to talk about a little bit is what it means to be studying at university. So it's an interesting thing because I'm going to assume that the majority of people who are studying this course were in high school last year. So we get into a situation where you switch modes of education. In high school, we're in a very, very structured environment. Everything is regimented. Everything's like kind of, you go to this class, the bell rings, you go to another class and things. University, there's no bell. I think that's like one of the fundamental differences, right? There being no bell means there's nothing to tell you where you have to be at any point in time. There are no fences around the university that force you to stay in when you have to be there. In fact, the course COMP1511 that we're in right now has no requirement for attendance to any of the scheduled content. If you can't make it to the content, at least everything's recorded, so you can go back and view it later, that kind of thing. And so what we're talking about is a certain level of freedom for you to choose how you're going to access the information. And also, I'm never going to say to you that that my way is the only way to make things happen. I'm just one programmer out of millions of programmers in the world. And then there are going to be other programmers are going to do things in a different way. They're going to approach the same problems that I am in a different way. I'm going to try to give you things in a really clean and formal way so that you can take what I've taught you and sort of branch out and to personalize things into the way that you want to do them. We're all going to be different in the way that we program. And it's also the same in terms of the way that we learn. Now that we're at university, you have freedom and you have control. So what happens is you can learn the way that you want to. You can be here in the live stream, and I notice about 50% of the course right now is here in the live stream. I'm seeing 230 or so people out of our around 500 people. Um, and that means that I don't know. I guess the rest of the people are going to watch it later on. It's going to be uploaded to Echo 360 on UNSW. It's also going to be on my YouTube channel as a public video afterwards. You can watch it. The interesting thing about having this freedom is you have the freedom to succeed and the freedom to fail. You have the freedom potentially to just not turn up to anything in the next 10 weeks and not really learn everything that you needed to learn, but that's your choice. Right, I'm not saying that's a great choice, but it's your choice. The other thing that's interesting is that you can reach a point where you can be partway through a degree and you can say to yourself, this isn't clicking for me. This is not something that is fulfilling me. This is not the kind of education that I'm interested in right now. And the beauty of being somewhere like UNSW is I don't know how many degrees there are at UNSW, but I think it numbers in the hundreds of different degrees. Which means if you find out that the degree you're in is not necessarily something that really works for you, there's plenty of ways to try out other things. You can take an elective or a gen ed in a different field, and you can say, having seen that other field, the introductory subjects in another field, that's clicking with how I think. That's fulfilling me in a way that makes me want to know more about it. And then you can transfer into those programs. What I used to say when we were in person is you can stand anywhere on UNSW campus and throw a rock in any direction. Don't actually do it. But you could throw a rock in any direction and then you hit a completely different field of study than the one that you know or you're particularly interested in. And there can be a whole mystery, a whole new world there to discover. So this freedom means that you are not locked in and you're able to make your own choices about what you can do. So it's an interesting way of looking at things. And I think people coming out of high school and coming into university, particularly, it's hard to grasp this level of freedom. So just have a think about that. It's something that's kind of useful. You are not forced into any particular structure. I mean, there's still structure. It's not completely open. It's not just here I have dropped you on the internet and I say come back and see me in 12 weeks and you better know how to program by then. We're at least going to give you content. We're gonna space it out. I have put together all the content. Well, no, I didn't put all the content of the course, but the idea of all the content of the course is it ramps up. So we give you things that you need, and then we give you things that build up on what we've told you before. So if you want to, following the course is probably an easier road to get to being able to program. But you do have the freedom to study however you like. There's lots of different ways to study for it. Yeah, so I see a bit of chat going. I'm not going to spend too much time in chat because it's a pretty dense lecture, but I think Tom's there answering a lot of your questions and stuff like that. Okay, so I want to talk about what is programming, right? Because like you may have signed up for this course saying, okay, I want to learn a bit about computers. I don't know what programming is. So what I like to think of program is the idea that we can talk to computers. So I could talk to my computer here and I could say, computer, I want you to write me a program that sends an email to every student in this course welcoming them to the course. And then, I can look at my computer and I go, well, I'm waiting. Why haven't you done the thing yet? And the computer is actually listening to me. There's a microphone on and things like that. But it is not necessarily doing what I asked it to do because it doesn't speak the same language that we do. Some computers understand English to a certain extent. If you've got like a Google Home or an Amazon Alexa or one of those devices, they can understand a certain amount of English. They can't necessarily build an entire tool just based on us speaking to them. So what we need to do is we need to learn the art of programming. And the art of programming is figuring out how we can communicate with our computers in a language that we both share. And that's what a programming language is. It's a language that we can learn to understand and computers can understand in a certain way. So if we can get this bridge, this shared language between us, we will be able to then ask our computers to do things for us. And this is deeper than just saying, just do exactly what I told you to do. When we're programming, what we're going to do is we're going to be learning about problems, and we're going to learn about problems and how to solve them. But the trick with computers, one of the things that makes them so wonderful beyond just this idea of solving a problem, is we could give a computer a procedure for solving a generic problem, and then we can give it a problem it's never seen before, so long as it's reasonably similar, it's in the same format of what we're talking about. We can give the computer this new problem and say, apply the procedure that I gave you before, and the computer will then be able to apply that procedure to the problem and solve the problem, even though we, in a sense, taught it how to solve a particular kind of problem, but not the one that it was given. So this is the beauty of what we're doing with computers. And so eventually, when we get to a certain point with our programming, we can say that I have created a program that can. So the example I was talking about before, I wanted to create a program that was going to email everyone in the course. And you know that I've already got something like that, because every time I send out a course notice that goes up on our WebCMS page, WebCMS is the name of our subject hosting system. Because it emails all of you. So all of you, and you should check your UNSW email if you haven't gotten any emails, have gotten the course notices as emails. So that thing already exists, which means what we've done is we've already got something we've created that is able to do that. And if I pull out all of the email addresses from the current crop of students, so all of you, and replace them with another group of students. We'll do this every term when we roll over to another group of students. Even though the computer has not seen all of these particular email addresses before, it's still able to do what it needs to do and send out something to all of those. So we're talking about the ability to not just do one thing, but be able to work with problems that were unseen up until that point. So let's look a little bit about at the course COMP1511 and what we're going to be doing in it. So we don't have assumptions of prior knowledge in this course. We do have one minor assumption, is that we expect that you've already used a computer in some way. So we're expecting what I would consider to be basic computer literacy. You know how to type things in on a computer. You've done a bit of, say, opening programs and things like that. I know I'm in a way preaching to the converted here, because it's very, very hard for you to be here right now watching this live stream if you can't at least use a computer to a certain extent. So this means that you're probably at least computer literate enough to open a browser window, find the link to this live stream, and open the live stream. So if you've gotten that far, that's probably all that we're assuming for prior knowledge. Sorry, the word that I'm covering up with my face there is prior knowledge. So what we're going to teach you is how to think about programming, which means this idea that we are not giving the answer to our computer, but we're giving a procedure to our computer with which to find answers, is something that takes a little bit of thinking about for us to get our head around. We're going to be teaching you a lot about the C programming language. Heaps of our technical stuff in this course is going to be about learning C, and in between learning C, we're going to learn a lot of generically useful stuff about how to just get around computer problems and things like that as well. We're going to talk about how to solve problems as well. So we're talking about how to solve problems in general, and then how to apply code to those problems. It's a bit sneaky. Underneath everything, what I'm teaching you is a little bit of what we consider to be the engineering process. So you may notice that this course is run by the School of Computer Science and Engineering, which is under the engineering faculty. So underlying everything that we're doing is the idea that engineers are people who solve problems out in the world. So we see things that are or aren't working for humans, and we figure out a way that we can build something to help solve human problems. So we're going to sneak a little bit of that in here and there about what it means to sort of take a problem, pull it apart, solve as much of it as we can, and then provide a solution that actually makes sense to people. So Down to the nitty gritty, the course format itself, we've got our lectures. These are our lectures here, scheduled twice a week, 2-hour blocks. We've got some live streams. Live streams are going to be very similar to lectures. I mean, there's going to be the same format. It's going to be me here live streaming over the same channel. But live streams will be more informal, and they will be, in a sense, bonus content where we will talk about things that aren't core to the course but might be useful to you. So when the assignments come out, I'll do some live streams just saying, okay, this is the format of the assignment, this is how it goes. It's not about what theoretical content you need to do to complete the assignment, but it's more just like, let's go through the assignment spec and make sure you don't get lost in anything or caught up in the way that we've written things or anything like that. You've got your tutorial and lab sessions. I'm going to bundle those two together because they are bundled together. So when you have your tutorial and lab, it's 1 3-hour block of learning. So the tutorial is going to be some information delivered to you by your tutor. The lab session is going to be a lot of you doing some work and then going to your tutor for advice. I've got slides on each of these anyway, so I should just sort of roll into it. The stuff we're going to be handing in are going to be weekly tests and assignments, although you hand in work in the labs as well. I'll talk about those in a second. And we also have help sessions, which are drop-in sessions where you can come along and just get one-on-one help from a tutor, ask questions and things like that. So that helps a lot when you've got a particular problem that isn't necessarily something that you need other students to know about or anything. We've got our course forum. Course forum's a great place to ask questions. It's also a great place just to search for answers to questions because we've got 500 people in the course. So there's a very good chance that if you have a question or you've got a problem in what you're doing, that someone else may already have asked a question about it. Okay, so let's launch into some details. We have a 10-week term. If you've been at UNSW already this year, you'll note that UNSW has added in a flexibility week, which is sort of a mid-session break, but also sort of not. It's like half a break. So in week 6, we will not have any tutorials and labs, but in that flexibility week, we'll have some lectures anyway. I will probably still deliver 4 hours worth of lectures, but nothing that I say in those 4 hours will be anything new. So there will be no new content that I haven't taught before. And if it's accessible content, if it's anything that's going to be in the assignments in the exam, it will be content that I've already taught you that I'm just going over again. So that's what week 6 will be. There will be no tutorials and labs in week 6. And there will be no weekly tests in week 6 as well. I'll talk about what those things are in a second. The help sessions, which is optional, where you can go along and get help, they'll still be running in week 6 because we will have an assignment deadline sometime around the end of week 6. So we'll still be supporting you while you're working on that. Okay, details about each of the parts of the course. So I've already kind of mentioned these already. You've probably got a decent idea about what the lecture is because you've gotten half an hour worth of one so far. A lecture is going to be me delivering content to you. It's going to be dense, it's going to be a little bit fast, it's going to be me trying to just ram content into your head as fast as possible. I suggest that lectures are worth it to be in. Don't try to absorb everything from the lecture in one go. Don't try to get to the end of the lecture knowing everything that I've said. It's not the kind of format that works that well for that. It's a pretty good format for, I watched that once. I might need to go back later and rewatch these things. So if I want to come back later and understand exactly what went on, then maybe I will do that. It's like a Christopher Nolan movie. I haven't seen Tenet yet, but from what I hear, it's basically like an academic level lecture. And to actually understand what went on in that movie, you're probably going to have to watch it more than once. Yeah. So these are going to be online via this YouTube channel that we're on right now. If you don't have access to YouTube, and I'm speaking now to the people in the future who are going to download this later and watch it, they will also be shared on the class webpage. So we've got a link to our UNSW Moodle, and the lecture recordings will also be on there. So I know that because we've got a lot of people in different countries, YouTube isn't readily available everywhere. The live stream isn't readily available everywhere. So we're still going to make it available for you. Okay. The live chat is always open for questions, as you can see. Live chat's going right now. Sorry, my camera's between my two monitors, so you can see if I'm pointing at this side, that means I'm aiming at the live chat. If I'm looking over here, it means I'm looking at the slides. So I will probably you'll get the feeling that when I'm pointing either way, where I'm kind of going. So this is a rule that I have, and this is something that I want everyone to be thinking about when they're using live chat. The only rule I have for this course, I mean, there's all the little rules of the course, like, don't cheat and stuff like that, but no one disrupts anyone else's education. It's a simple rule. So if someone comes into the chat and starts spamming a whole bunch of stuff and not let other people ask questions because they're filling up chat with, I don't know, ads for idle games or something like that, then what they're doing is they're taking away other people's chance to ask questions. And that breaks my rule. You're disrupting someone else's education, right? If someone comes in and starts making other people feel uncomfortable about being here, so if someone comes in and says, I don't know, all people of a certain creed or a certain religion or something shouldn't be here and shouldn't be allowed to study computer science, that would be something that would be making a whole lot of people uncomfortable. That would be disrupting other people's education. So what I'm going to say is you can disrupt your own education if you want to. As I said, you have the freedom, you have the choice. If you wanted to turn off this stream now and go play computer games, actually I could, no, I'm kidding. I would love that. For me, not for you, right? I'm not going to disrupt your education, so I'm not going to break the rule either. So I'm not going to just suddenly turn off the stream and go play computer games, because that would disrupt your education. But if you want to do that and it's not hurting anyone else, that is still your choice. But you don't get to choose for other people. And so that's what that rule is. You don't get to tell someone else to then turn off this stream and go play computer games. I mean, you could try, but I'm hoping that most people won't take me up on that. I just looked over at the number of viewers and hoping that number just doesn't suddenly drop. But yeah, so that's the trick. You don't make other people uncomfortable. You don't take opportunities away from other people. This is more subtle in some ways. Certain levels of helping other students is taking away the journey that they need to go on to understand what's happening. So this is an educational theory thing. If I was to say to you right now, I will now write down all of the answers to what's going to be in the exam at the end of this course, and I will write down all the solutions to the assignments. I'll do that now, right? If I did all of that stuff for you right now, you would all pass the course. But what I will have done there is, in helping you, this is an extreme example, but in helping you, I've taken away your chance to learn. So that breaks the rule, right? That disrupts someone else's education. So just be a little careful with that, right? So just think about that rule. It's a really simple one-liner, and it can help you decide what kind of interactions you're going to have. I'll talk a bit more about that later. I'll go into more detail, but I just want to mention it here in lectures, because the lectures are the first point where we're going to have a whole lot of direct contact with each other, because we're all in this chat. So we've got, like, a couple of hundred people in a chat window together. If we were to put a few hundred people in a random chat anywhere on the internet, something will always go wrong, right? So I'm hoping that if you follow that rule, you will try to remember not to be someone that makes it difficult for other people. Okay, lecture content. I think I've already spoken a little bit about this. I'm going to deliver a whole lot of theory in the lecture content, and I'm going to say, what is it that we're looking at? So every lecture is going to have a particular topic that we're looking at. I'm going to say, what are we trying to understand? Maybe I'll draw some pictures. Maybe I will talk about what kind of problems we're trying to solve today. I'm going to show maybe some demonstrations about code. I will probably be spending about, I'd say about 20-30% of the time in lectures, I will actually just be coding here on my computer and talking to you about the code that I'm creating. Usually it will follow directly from the theory of the code. So I guess I should have done these in a different order. The theory is what we're trying to understand. The problem solving is how do we decide what to code, and then the live coding will be the actual code that we use. The other things that we're going to talk about is outside of actually generating computer code that runs on the computer. I mean, I'll talk more about what all this is later, by the way. But outside of that, what is actually important to becoming a programmer? So this is a lot of like, how do we think about what we're doing when we're programming, and how do we think about how we're going to work and how we're going to work with other people, things like that. So there's a lot of like little things I'm going to teach you there that are potentially very, very important that have nothing to do with writing code. So there's a lot of other stuff to think about. We'll take that as it comes. I don't want to say too much about it because they're all kind of complicated topics. So slides and all other course materials, again, course website here. The lecture recordings will be in a playlist on YouTube, and they will be, they will be publicly available then, and there's also going to be copies of all the lecture videos available on Moodle. All right, so let's go into tutorials now. So tutorials and labs are going to be rolled in together. So the tutorials are roughly 1 hour tutorial, 2 hour lab. Because they're all in one Blackboard Collaborate session, we're going to be a bit more fluid with those. What's more likely going to happen is it's going to be closer to maybe a 1.5 hour. So the tutorials are a chance to sort of get closer to the content interactively. So we're going to have a tutor with you talking about content. So they're going to be going over the same content that I've gone over in lectures, but in a different level of detail. So usually closer level of detail, and in a way where you can actually interact with them. So tutorials are a good place to kind of stop and ask questions and things like that, as opposed to lectures where it's unlikely that I will pause lectures that often to answer questions, but I will occasionally. We'll be, I think there will be points at which I will stop for questions in lectures, but tutorials are much more interactive. There'll be times to ask questions a lot. They will be more happy about stopping and starting and looking at content. So the tutorial questions for the first tutorial are already available. We'll be releasing the tutorial questions for each week on the weekend before that week starts, so that you can go through and see what you're going to be doing. The links to Blackboard Collaborate are available via our Moodle page, which you can link to from the course webpage. The tutors will also have sent you links for the first one via email by now, I expect. If they haven't sent you a link yet and you're later in the week, they may just be about to send it sometime soon. Oh, there is a good question there, so I am going to pause every now and then. There was a question there about, do we complete tutorials and lab questions before the lab, or save it for the lab and tute? You don't necessarily have to complete them before the lab. So your tutor is going to go through them. It's not a bad idea to look over them if you want to, but your tutor's going to step through everything with you. I mean, if you do want to prepare questions in advance, you can look through them. So it's not the kind of tutorial, like some classes will have tutorials where it's like, do the reading before the tutorial. If you haven't done the reading, the tutorial isn't very useful. We're not really at that level. I would suggest, though, to watch lectures before the tutorials. So if you're not here right now, so I mean, obviously this question is not for you because you're here in the live stream right now. But if you didn't make the live streams the week before, then it's good to watch those. So the way that our content is set up is we've got our lectures, we've got our tutorials and labs, and then we've got our weekly tests. I'm going to talk about the weekly tests in a second. The content will go in a string of 3 weeks like that. So the lectures will be 1 week, the tutorials and labs will be the week after, covering the same content, and the weekly test will be the week after that, covering the same content. So you'll get one piece of content that stretches over 3 weeks. Because that's a really good way to kind of get an introduction to the content, a deep working of the content, and then a kind of an assessment of how you went on that content. And that way, when we stretch it out over the 3 weeks like that, that kind of narrative gives you a complete idea of each piece of content we're giving you. Okay, the tutorials flow into the labs. So the tutorials and labs together are a 3-hour session. And it's all in the same Blackboard Collaborate session. So Blackboard Collaborate is basically a video chat system, but it's a video chat system that was built with specific educational purposes in mind. So with the lab session, you will be either working in small groups or pairs. I should say that everything that I'm saying here is actually for the online students. When you're in person, it is very, very similar, but you'll be in physical rooms. Your tutor will take you through those rooms if you're in person. When you're in person, the tutorial won't have computers, so you'll be in a classroom, and the lab will have computers. So there'll be more of a distinction between the tutorial and the lab if you're in an in-person tutorial. So you'll be working on lab questions. If you want to see some lab questions, you can open the lab that's available on the course website. Don't worry if you have no idea what's going on yet. I haven't shown you any C code, so there's no reason you should know yet. But your tutors will be talking you through some of that stuff. At least there are no tutorials and labs before this lecture. So everyone going into tutorials and labs will have at least some information on what's going to be in the labs before you get there. So labs are a great time to get one-on-one help from your tutors, because if you've got 2 hours and you've got, I don't know, the lowest number of people in a tute is around 20, so it's 20 to 30 people, and you'll have more than one tutor in your lab sessions actually. So every lab session will have more than one tutor. It gives you a good chance to actually grab, 5-10 minutes of your tutor's time and say, I didn't understand this particular concept. Yeah, I saw it in the lecture, but it didn't quite click. Here's what I've done on it so far. Can you tell me where I'm going astray here? And your tutor will be able to help you. The labs themselves are separated into questions, and those questions will count towards your final mark. So you don't necessarily, as I said, there's no attendance marks for this course. It's also honestly very hard to attend anything because it's all online. Actually, one could say it's easier to attend stuff if it's online. I don't want to say hands up in chat if you're sitting in your pajamas right now and you only just woke up at 11 for the tutorial, but I can understand if that's the case. So the marks will just be for completing the content, and the content won't be due during your lab session. They'll just be due at the end of the week. So if you want to, you can even not look at the lab content until the lab, start working on it in the lab, talk to other students about it. Lab content's really free and open. It's not going to come under the same kind of rules for individual assessment. We actually expect people to be in the labs talking to each other about how to solve these problems. We want you to be helping each other here. So at the end of the week, you will hand in the lab, and then you'll get marks for it by the end of the term. There are also challenge exercises in the lab. The challenge exercises earn bonus marks. That means they're not necessary to get full marks, but if you have, say, made a mistake in other questions in another lab somewhere, the challenge exercises could make up for any marks missing elsewhere. I should probably point out that the challenge exercises are named that way for a reason. They're usually much harder than any of the normal questions. Some of them are content that I would say is nearly not what we've taught you, but is a ramification of what we've taught you, an extension of what we've taught you. So if you really understand the content and you want to see how far you can push these concepts, then challenge exercises are good. I should say that they are not good if you are being really strategic about your degree and trying to get the maximum number of marks for the amount of time that you spend working on the course. Some people like to do that, like to min-max their coursework. Challenge exercises aren't for that. Challenge exercises are for if you want to explore deeper and learn something else that's different about what's going on. Oh, someone was asking about seeing marks. You won't see your marks immediately after doing the labs. We won't mark them until a little while afterwards, probably about a week or so later. And the first week does not count for marks for the tutes and labs. And I'm pretty sure the challenge is not. Yeah, Tom's already answering those questions. I'm going to move on. There is a system called auto testing, which when you run your code, we have another program in the back that's going to look at your code and it's going to tell you which bits are working and aren't. So generally, if the auto testing system is telling you that everything's okay with your code, generally that means your code's working. Okay, the weekly tests. These are a chance for you to practice what it might be like in a high pressure, time specific exam like environment. They're not exactly like the exam, but what you are going to get is you will get 3 questions a week in the weekly test. This is self-administered, so you get to choose how you do this. My suggestion for this is set a stopwatch timer or something for 1 hour. We actually have a timer on the webpage for the questions, so you can use that if you want to. Where you can set up 1 hour and say, all right, I'm going to try to do all 3 of these questions in 1 hour, and I'm not going to look at any content. So you turn off your web browser. I mean, you need your web browser to read the questions, but you don't look up anything else. You just try to see how much of this you can do with only your memory of the course content. And then you see how much you can complete, and you say to yourself, this is a measure of how well I know the content was taught over the past 2 weeks. So you can say, I have done this in 1 hour, and then I figured out this is where my progress is. If I can't answer all 3 questions, let's say I can answer 1 question out of 3, I might then write down, okay, these topics that were taught over the last 2 weeks, I need to go back over this one or this one and have a look at it later. So you know what you're going to revise for the exam in the future. And just in general, you know what you need to know for particular parts of the course. If you've answered, say, 2 or 3 of those questions, you can say, all right, I'm pretty good on this content. I don't need to go back over this content. I'm quite happy with it. If you want to, once you've done that, once you've had your 1 hour of like the high pressure situation and you've said, okay, I'm done, I've gotten a good idea of where I'm up to. After that, you have the whole rest of the week for the weekly test. You can just go back and work on it again if you want to. So we're happy to accept something that you've spent more than an hour on. Like, we will take any submission that you do for the weekly test. But what I'm suggesting is the best way to do this is to put yourself in that pressure cooker situation for 1 hour and see what you can do. Because the reason we have these weekly tests is not for us to know how good you are at something. We're going to be doing much bigger things for that, like assignments and exam. These weekly tests are for you to know where you're tracking, so that every week you have an idea of how well the course is going for you and which things you might need to study and stuff. So it's more of a service for you than it is for us to necessarily track how you're going. One thing that I want to talk about in terms of communication of weekly tests, like people asking if we can reattempt, yes, you can go, you can do the weekly test as much as you want. It's like the labs where you can actually submit it multiple times. We'll just take your most recent submission. The one thing about communication is, again, we don't want to disrupt other people's education. The weekly test is only valuable to you if you don't know what the questions are already. If you knew what the questions were already, you would get higher marks than you were expecting in the weekly test, and then it would probably be hiding the fact that you don't know things as well as you do. So be careful about this. We're not going to discuss the weekly test publicly until everyone's had a chance to do it. So it's a no spoilers policy. So I don't know if anyone was watching a lot of Game of Thrones when it came out. Everyone was trying. Well, some people were trying not to spoil it, and some people were spoiling it. It's like ruining the show for other people, right? So what we want to do is not ruin the weekly tests for other people. So we're going to try not to discuss it that much on the forums. You can still talk to your tutor about it. So if it's just a one-on-one conversation with your tutor, it's fine. The more we start talking about it with other students, the more we take away their chance to actually figure out where they're going in the course. Um, um, okay, Tom's answering a lot of questions there. Yeah, Tom, I think we're going to be Thursday 5 p.m. for weekly tests. Um, Thursday works pretty well for us, and there's no lecture on Thursday, so we don't have to dodge any particular time limits there. The exact times, you notice I haven't put the exact time deadlines in the slides anywhere, but the plan at the moment is that the hand-in due date for the labs will be Sunday 8 p.m. And the weekly tests the week after will be a Thursday 5 p.m. So we want to kind of stagger the deadlines through the week so that you don't have everything due at the same time. The first weekly test won't run until week 3, because when you think about it, I deliver content week 1, you've got tutorials and labs in week 2 about things, and then week 3 is the first point where we'll start testing the content if we're in that 3-week cycle. Okay, assignments. Assignments are larger scale projects. Assignments are entirely individual work, so they will be very different from the lab work, where we're expecting you to actively discuss these things with each other to learn from each other about it. Assignments, we will not have that, so you'll be working on these things alone. They're going to be bigger programs. They're going to be bigger programs than anything else we're writing in the course. You can think of an assignment as made up of several lab exercises chained together under one topic. Each of these is going to give you, we're going to give you 3 weeks to work on each of these, and there's 2 assignments. One of them is due in week 6, and the other is due in week 10. Assignments will give you a chance to kind of show how well you've understood what we've taught you so far. So each assignment's on a different topic based on what you've learnt at that point in the course. So the first assignment due in week 6 will be testing roughly weeks 1 to 4 worth of content, and the other one due in week 10 will roughly be testing weeks, I was gonna say weeks 4 through to 8-ish, but it's actually kind of weeks 1 through to 8 in a sense that it will be testing, because there's plenty of stuff that you're going to need from the earlier weeks in the term to do the second assignment no matter what. Assignment 2 is worth more than assignment 1, but assignments together are worth 40% of your final mark. So you can see where we've put the emphasis in this subject. The weekly tests and the labs are worth small amounts because they're just your regular work that you're going to be doing. But when we ask you to really show what you've learnt, that's where the big marks come in, so the assignments and the exam. The due dates will be, I think, the Sunday of week 6 and week 10. And if you do need to hand in late and things, there'll be a 1% off the maximum possible mark. So if you have to hand in something 3 hours late, the maximum mark you can get is a 97 out of 100. But if you get any less than that, you still get the mark you got. So we're not just going to straight up penalize people if you're late. You just have a ceiling on what your mark could be. Talking now about some of the other things that are happening during the term. Help sessions, as I said before, are optional, but you may find them very useful depending on where you are in the course and what kind of problems you're having with the course, because this is something to help people who are having really specific problems. So if it's like, my code is in a weird place, I can't get it to run and I'm not sure why, help session's a good thing for you. So these will also be held over Blackboard Collaborate, but instead of being a whole group of people together, we'll use these things called breakout rooms to put people in one-on-one sessions with tutors. So we have a system where you sign up during the help session saying, okay, this is my problem, this is the kind of thing I'm working on, and then you hang out in a queue there, and a group of tutors will go through that queue and try to talk to everyone who's come along to the help session. So they're quite good for getting clarity on things. Also, talking to your tutors is going to help for that as well, but also just solving really specific problems. So you can't talk to another student and show them your assignment code and say, can you help me with this assignment code? We're trying not to do anything like that because the assignment's meant to be individual. But if you go to a tutor and you say, here is my assignment code, I need help with this, the tutor's going to be able to help you because at least they know where the line is for where they should or shouldn't disrupt your education. So they're not just going to straight out give you the answers and ruin your chance to learn how to solve the problem. They're going to take you through the steps of solving the problem. So help sessions are really good if you're just stuck in a hole and you're like, I have no idea what to do with what I'm doing. Help sessions are great. They won't be starting until next week, so we don't have any help sessions this week. The course website actually has a link to it, but there's no schedule for help sessions yet, but they'll be scheduled next week. These will get really, really busy around assignment time, so I would suggest that when you're working on the assignments and you're going to get problems with the assignments, I would say start earlier, go to help sessions early. If you go to the final help session on the Friday just before the due date, know that that one's going to be really busy. You won't be alone going to that help session. It's going to take some time to see everyone in those. So just be careful with that because the help sessions do get busy, because with 500 people and us trying to deliver one-on-one feedback, you can understand how that might take some time. Okay, the live streams that I will be doing during the course. So I'm just looking at, there's lots of questions there, but I see Tom and Shrey's in there as well. Shrey's also one of our tutors. Looks like the two of them are answering all the questions, so I'm going to let them answer the questions in chat there. Live streaming is extra content. So I've spoken a little bit about this earlier when I was introducing it. I will be scheduling these as it happens during the term. I will definitely always do a live stream around assignment release times. So I will release the assignment. You will have a big document that says what the assignment's going to be. I'll leave that with you for a few days on release so that everyone gets a chance to read it, and then I will drop in for a live stream. And the live stream, I'll talk through the assignment and some of the details, and I'll answer questions. I usually do another live stream after the end of term. So we get to week 10, and then we've got week 11, which is the study week, and then week 12 usually is when the exam is. The exam period's long enough that we don't always know exactly when it's going to be, but it's usually roughly the 12th week, if we were still counting weeks by then. I will usually do a study session in week 11 where I'll basically hop in for a live stream, and while you're studying for the exam, you can say to me, how do I do this? And I'll be there and I'll help. So it'll be a bit of a, I won't have any content prepared for that, but I will help people with any questions they have at the end. Chances are I may do other live streams here and there, depending on whether I think that there's some side content to the course that we might need. I've been known occasionally to do social streams as well. I don't know if anyone has met Daniel Mansfield, the maths lecturer. Him and I occasionally will do a little social thing where we'll just hang out and chat. So the exam itself is a take-home open book exam. So this means that you'll be doing at home on your own computers. Open book means you will be able to use the internet to work on the exam. Now, I have to say one caveat about using the internet is that these open exams often have the idea that people will upload their questions to websites and other kind of tutoring resources online. Someone else will write the solution to the thing and make it public, and then while the exam is running, the answers is just floating around on the internet. Just be careful, because using those solutions that people have put up on the internet will immediately have you flagged for plagiarism, and then we'll be investigating not just that question in the exam, but everything else that you've done in the course. So just be careful when I say using resources on the internet. If something looks suspiciously like it's tailored like exactly to the exam question, chances are it's something that is again taking away your education, because the answer doesn't help you. The answer just takes away your chance to show that you know something. Anyway, the exam will be giving you a bunch of things to solve in the C programming language, also give you some C, and you have to read it and understand it and show what it is. We will go over the exam in detail later. I think there's not that much I can talk about the exam if I haven't delivered any content to you yet. But just know that it exists. We will have a time window for it. The time window that we run the exam is based on the location of the students who are taking the exam. So we only need, I'd say, 5 hours to run the exam, but it depends. If we put that 5 hour window in the middle of the night for someone studying somewhere else in the world, then we probably don't want to do that. So we're going to figure out where everyone is. Basically, if we have anyone studying internationally from the US, then we'll probably have to do something for those students. Otherwise, everyone else is going to be okay if we do something in a Sydney afternoon time. So a lot of stuff we're doing now that we're online and our international students can't actually come to Sydney, so we're having to just sort of make provisions to make things work. That's why I've said this is the expected workload, because this hasn't actually been decided yet exactly where this is going to fit. So there is at least one person who is studying from the US at the moment. Is it like midnight for you there now? Gira-chan is saying that. Anyway, we'll talk about that later. There are some other things in the course that we call hurdles, exam hurdles. So these are things that we consider to be competency hurdles. So if you are not competent in working in a particular way in code, then we can't give you a passing mark for the course. This is even if you've got great marks in everything else in the course. We're testing a few things in the exam that just say, without these basics, we can't put a little rubber stamp on you saying that, yes, this person definitely knows how to do what we taught them in 1511. Chances are, if you've been working through all the labs and the assignments and things, these hurdles won't be that hard. So, but they do exist and they are important. I won't say too much detail about what they are because they're about topics I haven't taught you yet. So, someone was... Oh, Gira-chan saying it's 9 p.m. now. Okay, that's not too bad. Anyway, here is the breakdown of all the marks as I've told you there. So 10% in labs, 5% weekly tests, 40% in the 2 assignments, and then 45% in the exam. Your marks for this course are very, very rarely scaled. This is now our sixth iteration of COMP1511 that I've taught. So I've taught it all 3 times last year and all 3 times this year. I've only scaled a small portion of marks once in that time. What I like to do is to give people back their raw marks that they've scored in the course, so you can see exactly how you went in the course. So you don't get the impression that I have scaled everyone so that I get a bell curve of marks. I'm not really interested in the bell curve. What I like to show people is just exactly the sort of feedback on how you've gone in the course. So in order to pass the course, you must score more than 50 out of 100 in all of these marks added up. You also must pass the 2 hurdles in the exam. So a little bit more detail, but don't worry if you don't understand what these keywords are. In general, I usually don't like putting keywords in a lecture until I've explained them, but kind of need to here. So solve problems using arrays in the exam and linked lists in the final exam. We are going to be spending a fair bit of time on both of these, so don't worry about it now. We'll get there. Just know that there are some questions in the exam that must be answered, at least majority correct, for you to pass the course. All right, if you have any need of help, and this is any kind of pre-existing conditions, or even anything happens to you during the course and you need help, the university can help with these things. So special consideration exists, which can do things like give you extensions, give you alternate ways of learning things. We can do things also like delaying the exam. The supplementary exam is something where if people have certain provisions and they can't do sort of multiple exams in a row, that kind of thing, we can give you a supplementary exam. Slightly awkward because the supplementary exam, there's no time to do it at the end of this year, but the supplementary exam will be in, I think that's the first week after the uni opens back up next year, so it'll be in January. We know that the supplementary exam week is the 11th to the 15th of January, but we haven't been scheduled an exact time yet. So if you have any need, there's always a way to help. There's a link there to special consideration, which will give you instructions on how to sign up for help if you need. There is a possible course textbook. And I say possible course textbook because I will not be teaching anything from the book. I don't actually have a copy of the book with me either, so I can't show you the cover or anything. In general, I don't necessarily use books that much for computing, but if you're someone that likes to work out of a book, this one is reasonably highly recommended. That will help you to learn a few things about C. It especially could be quite useful if my style of lecturing is not clicking perfectly with you. There's always another way to look at things. I say this is an optional book. I will not be referring to anything from the book, and I will not require you to have the book or to use anything from the book. But if you want to, you can use it. Okay, little bit about code of conduct. I'm a little bit over time, but we'll go on break very soon. So I mentioned this earlier, the one rule: you will not hinder anyone else's learning. And the university is pretty clear on this, that everyone gets a chance to learn. Everyone who's here, who's enrolled and wants to learn, gets a chance to learn, and there is no specific reason why your background, your situation, or anything like that should be a reason why anyone else would get in the way of your learning, or have any kind of option to stop you from learning. So what I want to say is that we will always be respectful of each other in this course. And that includes any communications or anything connected with COMP1511, any discussions you have in your tutorials and labs, and this does include any social media connected to the course. So we're not necessarily going to be going into your Facebook Messenger chats and telling you what you can and can't say or anything like that. You've got the freedom to do these things. But what I want to say is, even in those situations, please be respectful of each other. So I've got some things listed here, but there's way more than just these things that I would like people to be careful with, right? So no discrimination of any kind, no inappropriate behavior, don't harass other people. And the thing that I want to say about this is that we often forget that what we're doing is potentially going to hurt other people. And I hope that for all of us, if someone says to us, can you not talk like that? Like the way that you're saying things is making people uncomfortable, whether it's that person or someone else. If that's the case, please be respectful of that. Please just say like, yeah, okay, I've made a mistake here in the way I talk because I'm used to talking with other people who have a particular way of communicating, and I've made a mistake and it's made other people uncomfortable. I'm going to stop doing that. I'm going to change what I'm doing. So if we can have that attitude towards things, that'd be great. If we start, pushing other people and stuff, we're going to make it harder for other people to learn, and that's going to break the rule. So that's all I want to say about that. Please also respect other people's privacy. Don't be posting anyone's private information anywhere, including the idea that, not many people are going to be face-to-face or anything, but please don't be using other people's computers without their consent, or looking at any of their content without their consent. It's often just something that we just want to have respect for other people, but also the second you look at someone else's code, especially in assignments and things like that we're going to be marking individually. That can influence the way you write the code. Some of that stuff does definitely turn up in plagiarism situations where someone's looked at someone else's code, even unintentionally. The ideas lodge in their head and you end up writing the same code. And we will find that. It's like we've got some very sophisticated software for it. So it's real awkward when that happens. Tom's reminded me also that part of the code of conduct that we're meant to be following is social distancing. So if you are in person, we are following all of the government and the university's rules on social distancing. So I'm not sure exactly what that is going to be, but there will be rules on minimum distance between people. There will be rules on cleaning and contact and things like that, so that if you are in person, we're taking as much measures as possible to make sure that everyone's safe from the coronavirus, which is still floating around Australia a little bit. So even though there's not that much in New South Wales, we don't want any of it to be passing around people at UNSW. Okay, I want to talk a little bit about plagiarism. Plagiarism is the idea, and I've talked about this a bit here and there about copying each other's work or anything like that. Plagiarism is any presentation of someone else's work or even ideas as if they were your own. So if you take an assignment from another student or an assignment that has been posted up online and then you hand it in, anything that you submit to us as an individual assessment is basically you stating that you did this yourself. If you didn't do it yourself and you did it with other people or anything like that, then you will get penalties for what you've done. I mean, the simplest thing is if I find two people working on an assignment together, then if I'm going to be really, really polite about it, I'd only give you half the marks each. Usually I'm not that polite about it, frankly. So this is considered plagiarism. It's considered using someone else's work, using stuff online. If you are going to use things online, there are plenty of online resources that are really, really helpful. And you should be learning about how to use those. If you do need to use anything online, it's okay. All you need to do is just credit it. So all you need to do is put some information where you've used the code saying, okay, I learned this technique from this source and I've used it here. And that's actually like, that's most of the time going to be just fine. If it's like someone uploaded the entire assignment to this website, I downloaded it, and here's my credit saying I downloaded it from here, we may give you a 0 for the assignment because you didn't do any work on it yourself. So at least credit what you've used, but be careful not to just use stuff wholesale. I want to point out this point here at the end is the more that you just take raw information from somewhere else and submit it as your own, it's like, yeah, sure, I can just like take marks away from you. I can like threaten to kick you out of the university and all this kind of stuff. But the real point is that you paid a whole lot of money to do this. You're putting a whole lot of time into this. If you're not going to come out of it with having learnt something, then what was the point of being in the course? You know, even if you managed to cheat your way all the way through UNSW, I'm sure someone's doing it, right? Like, can make it all the way through UNSW, you get to the end, never having done any work, and you think, yay, freebie, I got a free degree. You're going to last like 3 weeks in your first job before everyone knows that you don't know anything, and then you just get fired. And then what was the point? What was the point of the like 4 years and thousands of dollars, or however much it's going to be for a degree, if you cheat your way through and you don't know anything? I feel like the aim of what we're doing in a course like this should be that we want to come out of the end of this not needing anyone else's help afterwards. We're going to come out of the end of this having competency, having the ability to do things and new knowledge and stuff like that. So if we can get to that, that's important. And anything that you do which involves taking answers from other people in any way just takes away your chance to actually learn that. So that's what I have to say about plagiarism. I also have a standing rule that if you feel like you need to cheat, if you feel like you're at a point where you are desperate enough to to need to cheat, send us an email, send your tutor or myself an email and say, this is where I'm at. So I have a standing rule that anyone who calls out to me in that situation and says, I'm screwed, I think the only way I can pass this course is by cheating now, if you send us that email, we'll make sure that you get one-on-one help and we will extend your deadlines until you've gotten one-on-one help. So we want to make sure that if you're in a situation where you feel that desperate and you're that far behind and you're having trouble, we will give you the help that you need. All right. There's a question there about masks in in-person labs. Tom, I think you have the information, the exact information about that. Can you answer that one? Yeah. All right. Be careful about thinking about the difference between collaboration and plagiarism. So discussion of things is fine. So basically anything that I have delivered in lectures, you can discuss that. You can teach each other about that kind of thing. The point where that crosses the line is where someone says that they're working on a very specific question in the assignment or in a weekly test or something, and they want to talk about that. At that point, you probably need to back out of that conversation. You need to say, no, we're not going to have a conversation about the specifics of those questions that we're being assessed on. But if you want to have a general discussion about a particular algorithm, so it's like an algorithm is like a an idea that gets programmed. So I should probably not have said that there without talking about what it is. So if you want to talk about a particular technique of like, okay, we want to look through all of the items in this list of items. I'm going to be generic about it. I'm not going to talk about specifics. Then you can talk about that. But if you say in the assignment, we've got this, this, and this, and we need to do this, that's the point where the conversation should stop, right? So we want to know where the line is. In lab work, we're really open. Labs were initially designed for people to not have to work on them on their own. It's harder online, but even in the online environment during the lab time, you can talk to other people about everything. Everything's really open. We actually encourage you to look at each other's code so that you can actually see how other people solve the same problems. All right, I'm not going to go through super detail about all of this because I think I've spoken a fair bit about plagiarism now already. Okay, so let's have a break. Sorry, the break is a little bit late. There's just so much content that I've got to cover in the first half of this lecture. So here's a little app that I found ages ago, and it's really funny because without having any proper code or anything, this little app actually teaches people a lot about what the logic is of programming. So check it out if you want to. I think there's also apps for smartphones for this, so you can actually play this little game and it will actually teach you some of the structures for programming. Okay, we're going to take 5 minutes. It is now exactly 18 past 12, so we will come back at 12:23 and we'll go through the second half of the lecture. Oh, you can still hear audio, you said. Ah, yes. Okay, I'm gonna mute that because you don't need to hear me during the break. Okay, we're back. Sorry, I have it's not my normal mic settings at the moment because for some reason I have two mics, one on my webcam, one on my laptop, and only one of them was working. Anyway, yes, the all of the overlays for the stream are my cat. So she started visiting us in lectures in first term this year because I started having to lecture from home. And since then, she's become the what we affectionately call the lecturer in charge of COMP1511. Anyway, let's let's continue with what we were talking about. Um, I want to give you some advice on how to succeed in programming, and this is advice that works pretty well for all kind of learning. When you're trying to master something, you're trying to learn about how to do something. There's one kind of golden rule is that yes, the more time you spend practicing and learning about something, the better you're going to get at it. Nearly all skills in life are not insurmountable, they're just a matter of time. The physical ones are a bit more difficult. Actually, they're even more a matter of time for building muscle memory. But sometimes just the raw physicality of some things is hard. But in terms of nearly anything that we're going to do at university, um, the more time you spend on something, the more you're going to get out of it. So we have set up a course so that we can get you through something with less time than you would need if you were just trying to grind it out on your own. So what I want to say is the best way to learn about programming in Comp 1511 is to try to complete all the work you can in the order that we've given it to you. It can be hard when we deliver content reasonably quickly. University is like that, and so this is again that difference between um, uh, the the difference between learning in a really specifically structured environment and learning in this kind of high speed university environment is we're just going to like basically turn on a fire hose of content at you for 10 weeks. And I should point out that it's not super important that you know everything in this course by the end of the 10 weeks, but you probably want to pick up most of the important bits. But even if, and there are definitely going to be parts of this course where I'm going to show you something knowing that you're not going to get it. So some of this stuff is hard, right? So don't worry if you don't get everything, because it might click. You know, it might be 6 months from now, something clicks and you just go, oh, I get that now. Like Mark showed that to me the first time, and I didn't really get it. And yeah, so I didn't get all the marks I could have in 1511. That's fine. But then later on, you can be like, another situation's going to come up using the same kind of concept, and suddenly you're going to be like, okay, now I get what he was saying earlier, and that links up with what's here, and now I understand. You know, so sometimes patience is very important for what we're going to do with learning. So one thing that people often get caught up in is where they're at and how much they know right now. And it's okay to be aware of that, but don't get too caught up on, especially caught up in competing with other students for how well you're doing on things. You think someone's smarter than you. Everyone who is able to do something, there's always going to be something that you're going to be able to do better than them. There's going to be something that they're going to be able to do better than you. There's no sliding scale. Well, there's no sort of one-dimensional scale of who's smarter than someone else. It's all just kind of like we're just a mishmash of skills that we've learnt. And it's not really important if someone else has a skill and you don't yet, because every skill is something that you can pick up. So, oops, where are we? I like to throw in a little meme every now and then. So, we can get caught up with all the things that we don't understand yet. But if we take our time and we know that we're going to pick things up eventually, and we have the patience to spend time on things, this is what learning is. This is how we'll get there. So I want to give everyone the opportunity to know that you're not going to pick up everything that I teach, and that's acceptable. It's okay. Pick up what you can, focus on the bits that you think are the more important bits, and take your time with it. So if someone says, I didn't learn everything I needed to in COMP1511, but then 2 years later, when I sat down and thought about it, and I'd looked at all this other stuff I'd studied, once I got to that point, I did actually know everything that I needed. It got me like close enough so that later on I picked things up. Um, so I like to say that, a lot of people are wondering, like, this question of like, can some people do computing and other people not? Is it something that only certain people in the world can do and other people are just never going to be able to do it? I don't really hold to that philosophy. I hold to the idea that everyone could learn how to do basic programming if given enough time to learn, if given enough time and space to learn. So if you want to, you can get there. All you need to do is decide that you're going to get there and have the patience to get there eventually. Okay, that was the overview of the whole course. If you want any more information, the course webpage and the course forum has a lot of stuff. There's also the recorded lectures. If you want one-on-one help sessions, or asking your tutor. If you need to email us, this is the email address that goes to me and Tom. So this is like the official admin email. There's also other places at UNSW to get help. So there's the student nucleus. This is going to be the first point of call for anything. So anyone who had issues that needed special consideration for, you actually go through the nucleus for that. They can give you specific support if you need. CSE also has this thing, the help desk, which is there, which can help out. There's other resources which I forgot to put on the slides. The School of CSE actually has student representatives. So Tom or Shrey there, if you know the link to give people access to the StuReps website, can you check that in the chat now? So we have student representatives who are there to advocate for you. So if you're having any problems with the course, and you don't just want to email me about the problem, so what if I'm the problem in the course? You need to tell someone else about it. You can tell the StuReps about it. The StuReps can happily take any grievances that you have directly to the head of school or other people if necessary. There we go. Tom's got the web address there for the StuReps. How your son's asking about time information. Yeah, timetables are on the course website, and the lecture times are also there as well. So the course outline has a lot of that stuff. The lectures section that has all the slides and everything that I'm going through here also has the exact time that the lectures are going to be. I should warn everyone in advance as well. Sydney is going to go through a daylight saving switch during this term. So I will be bombarding you with emails to make sure that everyone knows what the time switch is and when it happens. So it's around the start of October, so it's in a few weeks. Oh, you were asking about deadlines. Everything that we work on will show its deadlines. So all your lab questions will tell you when they're due, and the assignments will tell you when they're due. They'll be in the questions themselves. Okay. Another thing about email, please make sure that you can get emails at your UNSW email address. It's good to check this now because we will be using your UNSW email addresses for important communications. We will also be doing things like administering the exam via emails to your UNSW email addresses. So check those, make sure they're working. We've already sent out several emails to your UNSW email addresses. So if you've been enrolled in the course up to this point, you can check to make sure that you've been receiving emails. If you haven't been enrolled up until this point, then we will still be sending out notices. I will send out a notice every week. So every week, usually on a Sunday, I will send out a notice saying, okay, this is what's coming up this week. So make sure you're receiving those in your CSE, sorry, not CSE, UNSW emails. And if you are, everything's okay. Oh, forgot to say, if you do email us, please use your UNSW email address. That means that all the communications is official. And please let us know your ZID when you're emailing us so that we know who we're helping. Sometimes we have a very awkward situation, and you can get this when you've got 500 to, we've even had more people in this course in the past, where two people in the course have exactly the same name, and it makes it hard to help people because someone says, I would like uh, someone says, I would like help, and I'm this person, and then we look up that person to try to help them, and what they're asking about is completely different from the things they've been submitting. Okay, so let's talk a bit about what a computer is. So a computer is a tool, and it's a machine that we as humans have built. Um, but the interesting thing about a computer, the thing that makes it very, very different from most other tools that we've ever created as humans, is it is a very, very highly reconfigurable tool that can be used for many, many different purposes, all based on the idea of storing information and calculating something on that information. So the key elements to it are these two bits. There's a processor. This is the thinking bit. The thinking bit can do maths. It can make decisions to a certain level, and it's going to be the kind of the brains of it in a sense. But then we also have memory. Memory is our ability to, in a sense, have our computer write things down. So say, okay, this is some information that we're storing, this is information that we're going to keep, information that we can give back if necessary, or we can read again if we need. So everything that we're going to do with our computer is going to be based on one of these two things. We're either going to be keeping information, or we're going to be processing the information to do something different. I want to talk a little bit about the history of computers, because it's a lot of fun to think about these things. When we're looking for who to credit for being the originators of modern computing, one of the points in history that we like to talk about is this pair of people back in 1835, which was Charles Babbage and Ada Lovelace. I would say that the history goes back much further than that. The history of theoretical thinking, logical thinking, and things like that goes back significantly further. You want to look at mathematics and numbering systems in Persia and ancient Greece as the kind of the cradle of modern technical thinking. But when we look for the first point at which a machine was thought of that was able to do programmed calculations, that's probably Charles Babbage's analytical engine. And so here he is, the mother of all computer programmers, Ada Lovelace. So back in 1835, these two came up with the concept of a machine that could do numerical analysis, but not just numerical analysis. It could follow procedures, and it could theoretically, it was never built. Well, they never built it, which is interesting, right? So without ever having built a computer, they came up with something that could have the idea of following procedures and changing what it did based on the data that it saw. And so Ada Lovelace was the first person to write computer programs. And this is like super hard mode. The computer did not exist. The analytical engine that she was working on the idea of didn't exist. So Charles Babbage had designed it but couldn't build it because mechanically it was mechanical. You can see pictures of things people have built based on his designs now. It's this huge bank of cogs and things. So it's exceedingly physically complex. She was writing programs without ever getting a chance to run them on the computer. So she was writing programs on a purely theoretical level. So I think it's really cool. So you think about, like, if I said to you, I want you all to learn how to program computers, but I'm not going to let you use any computers. You just got to write stuff down on paper based on the theories that I give you. That's where she was working. So I think it's really cool. I think it's always a good thing to think about where the sort of beginnings of what we do came from. I'm going to jump forward in time to this century when computers started working with actual electrical digital circuits. So the precursors to what we have now, the integrated circuits that we use now. This man here is known as Alan Turing. So Alan Turing is thought of as the father of modern computing, because the work that he did in the 1940s allowed the Allies in World War II, the UK specifically, to break the German code. So the Germans had a particular machine called the Enigma machine that was able to make all of their radio transmissions encoded in such a way that the UK the radio operators who were intercepting those signals wouldn't be able to read them. So they built this computer, which back then was like a warehouse worth of computer that is probably less powerful than a tiny portion of this thing here. So interesting that that's what they were working with, but they were able to break those codes there. And it's one of those quiet effects of World War II that wasn't like, people running around and shooting each other and stuff like that, but it's considered to be one of the points that was actually quite instrumental in the finish of World War II. What Turing also did is he came up with this theory of computation. The idea that there is a processing bit and there is a memory bit. This is his theory from the very beginning. And he came up with the concept of a Turing machine. The Turing machine is pretty simple. We're going to actually look at it later, but I'm not going to talk too much about it now because I'm looking at the clock and I know we've got a little bit of time left for what I want to teach you. But the Turing machine had a theoretical capability of what it could do. And the interesting thing was, it was the idea of like a piece of paper and writing stuff on a piece of paper. There is no computer in sort of commercial circulation, the stuff that we normally use. So I'm just caveat, because quantum computers do things differently. But all of the normal computers that we use, there is nothing that any of them can do that his theoretical model couldn't do. So back in the 1940s, he predicted what computation was capable of doing, and he came up with the most simple possible theoretical model for computation, and we haven't surpassed it yet. So we've had 70 or so years to work on that idea and see if there's anything more, and we haven't found anything yet. So I think it's really interesting. Okay, so what are we doing now? What are you talking about? Oh, you're talking about the movies. Yes. There has been a movie recently with Benedict Cumberbatch called The Imitation Game, which talks about that particular era of Alan Turing's life. So it's pretty cool. There's also books about him as well. A lot of tragedy there. I'm not going to go into it now because we want to talk about computing. So I chose to celebrate his achievements rather than the horrible things that were done to him. Anyway, we'll move on. Okay, so now we live in a different world where there's so much more computing capability. And so there's a whole lot of options that we can do. So I've listed a couple of things here, which are interesting. So if we want to, we can do global simulations of weather and climate patterns, things that are probably coming up a lot. There's a lot of issues with changing weather patterns nowadays that we're trying to at least predict what's coming. We can connect people globally in communication networks. The fact that we are here in this lecture right now means that we have a global connection. We're doing live streaming, chats coming back. People were talking from America and other stuff, and just like we're open. We're having this discussion here, which is really cool. We can simulate highly complex virtual environments. Every big 3D computer game you've played is leveraged on the complexity of code that people have written in the past, as well as the complexity of the machines that we're using. I always like to throw this one in here for fun. Deciding what you want to watch next on Netflix. It might seem simple, but it's actually like really, really full on. That company is based nearly, like, I think the profitability of Netflix is based on how well it can recommend new shows to people. So I think there's a whole lot of stuff going on. So this is where we're headed. And this is where you're headed. You've just started taking your first steps along this path of learning how to get computers to do things. And so who knows what's next, and who knows if you're going to be part of what's next. And so I thought that'd be an interesting thing for people to think about. Okay, so how we're going to be doing things. So we're running Linux on the labs at UNSW, and we have something for everyone who's studying online called VLab, which is a virtual lab. So that allows you to connect to our computers, and it will be the same interface to the computer as it would be if you were sitting in front of one of our lab computers. We use Linux as our operating system because that is something that's used a lot professionally, and it's used a lot to um, because it's an operating system. So we know some operating systems like Windows and OS X and things like that a lot of people are using. Linux is a very, very configurable operating system. So a lot of businesses will use Linux rather than the commercial operating systems in order to have things set up exactly the way they want for their development environments. Simple though. The only things that we're going to need to study COMP1511 are a connection to CSE's resources. So there's a couple of different ways to do this. Our home computing links on the course webpage can help you with that. Your tutors this week in your labs will help you with this also. But basically what we need is a text editor, which is a way for us to edit our code. All of our code is just text. And a compiler. A compiler is a program that translates our code into something that our computer is going to read. So we will write code in a specific way, translate it, and then the computer will understand it. I'm going to talk about that more in a sec, actually. So, should at least tell you a little bit about what an operating system is. So, we've got our computer hardware. You know about the computer hardware, at least to a certain extent, because it's sitting in front of you. I'm not going to go into the details of exactly what the hardware is, but know that you have bits of your computer that do some thinking, and bits of your computer that memorize stuff, and then all the hardware that says, okay, when I press this key, something happens. When I click on the mouse, something happens. Your operating system sits on top of that hardware, makes sure it all runs. So that says, okay, we're going to manage which bits of memory are going to be used for which things, when the processor is going to do things for different programs. We are going to be writing code that links up to an operating system that then runs on the computer hardware. So that's the kind of hierarchy of what we're going to be doing. So the Linux terminal is one of the main interfaces to programming that we're going to use. I'll probably hop into a terminal in a second, actually. So, in fact, let's do that now. So this is the connection to VLab that I've got. I've already set it up. I'm going to log in here. This is what it would look like if I logged into a computer at CSE in the computer labs. The very first time you'll log in, you'll have some setup to do. So I've already done that setup here. So this is a terminal. This terminal allows me to type things in so then I can get some information here. So in my slides here, I've got some information. ls allows me to look at what's in a directory. mkdir. I apologize at the moment for the 1980s text here. So a lot of Linux was built in the very, very early days of computing. In those very, very early days of computing, they were actually worried about how many letters they could use for each particular thing. And so you'll see a lot of things are going to be abbreviations of things rather than being rather than necessarily spelling everything out. So we're going to need to at least be able to look these things up or memorize some of these things as we're using it. So ls is a listing. This lists everything that I have for in my directory. And as you can see, most of my directories here are just each iteration of COMP1511 that I've taught recently. So I've made a new one here for the current one. And so if I want to look in this directory, I press CD, change directory, type in COMP1511, and now you can see here it's showing me I'm in that directory, and I press ls and I can see what's in there. If I was to open a file manager like this, so you're probably more familiar with these file managers, basically what I did there is I opened COMP1511 and I can see in there I've got this thing called helloworld.c. That's the program I'm going to be showing you in just a second. So as we go through, we're going to be using the terminal more, and we're going to be seeing how we navigate things in Linux. Okay, so the basics that we're going to use here is a text editor called gedit. and a compiler, the compiler being something that we use to turn our code from a text file that we're writing stuff in into a program which is actually like an executable file. So when we're looking at apps and stuff like that, that's the thing that you click on or you tap on your phone or whatever to actually run something. So we're going to be using these two tools. I'll show you a bit of that today. So I said before, programming is a bit like talking to your computer. So the shared language that we're going to have with our computer here is C. So in one form of C, we can understand it. And I mean, like, you know, we can't understand all of it yet, but we'll get there. And the other form is after we've compiled it, then our computer is able to read it and run it. So we'll talk about compiling in a second. What I should say about what C is, it's not like a human language in the way that we speak a human language. When we're speaking a human language and we're not entirely clear on what we're saying, people can often still understand us. There are some ambiguities in there, but we can still understand most of what's happening. Programming languages and computers are not exactly at that level. They will be very, very specific about what you say. They're specific about what you spell, specific about exact punctuation that you're using, and if you're not exactly correct, the computer will just say, no, I'm not dealing with this. I'm not able to read and understand exactly everything that you're doing. So that's one thing that we're going to have to learn to deal with in C. We're going to have to learn to work with that. I said before, actually I was talking before about how a lot of modern programming languages are based on C. So we're going to be learning C. I like C because there are some basics we can learn. There are some fiddly bits because it's an older language. But there's some things that we can do in C that we can't do in other languages. And what we're going to try to do is teach you a lot about how a computer works because of how close C is to a computer. Okay, let's have a look at some C. Here is a C program and some of the components. So this is a very, very basic program, and I'm going to open it here in our text editor. So to open our text editor, I will type in gedit, which is the name of the program that's going to open the file. Then I'm going to type in the name of the file itself, helloworld.c. Even if this file doesn't exist, you can open a file with a new name if you want to. I'm going to do something strange, which you probably haven't seen before. I'm also going to put an and at the end. So apologies this went over one line. Actually, let me just... Oh no, I can't expand the window after the fact. Anyway, it went over one line. This and here is just a particular thing that we type in that allows the gedit window and this terminal window to both run at the same time. If I didn't put the and in there, it jumps to the gedit window and the terminal window becomes unresponsive. So I want to use them both, so I put the and in. In general, if you want to, you can just put this and in every time you use gedit. This opens my gedit window. I'm just going to shrink that a little and put it over here. Actually, I'm going to put it somewhere where my face isn't. I'm just going to check what the output of the stream is looking like at the moment. Okay, so here we have our first look at some C code. And this contains a lot of the main components that we're always going to use in a lot of our C programs. And then a section where we're going to be editing things. So I'll go back to my slides and we'll talk through some of the stuff that's in here. So, comments. I'm going to say this again in the future, but what we're going to be doing with our code, and it's really interesting, is that I say roughly half-half. Half of our code is for the machine, but fully half of the code we're going to write is actually for humans. Because when it comes down to it, if we don't write code that other people can understand and other people can use, what we end up is in a situation where we have this magical, like it's like a magic spell. We write a magic spell and no one knows how it works, but they just know if they repeat the words out of it, then it does something. We don't want our code to be magical spells. We want our code to be something where someone else can say, I can see what you did there, and I can actually change it to make it do something else. Or that someone else might even be you. So in the future, you might look at your code and you might say, I have no idea what I wrote there. I don't know what's going on. So we don't want you to end up in that situation, which is why we write a lot of code for humans. So comments are actually going to be ignored by the computer. The computer will never read these lines, and I have made the signifier to the computer to not read those lines by putting these double slashes in there. So if I put those double slashes in there, I can write some stuff here that is purely for humans to read. As you can see, I've written this in basically plain English. I put my name in there and the date that I worked on something, and said a little bit about what it is. So this is a standard comment that we're probably going to be putting in most files that we create, which just says who I am, when I've worked on something. People often put their email address in here so they're contactable. You will likely be wanting to put your ZID in there so you can just claim it as your own work in a sense. And a little bit of an explanation about what this program is. The bigger and more complex our programs get, the more information we may end up putting there. So there's two ways we can do comments. One is with the double slashes for a single line, but then we can also use these symbols, the slash and the asterisk, to say that multiple lines, everything in between those lines are comments. We then have a hash include. I'm not going to go into a great amount of detail about the hash include because the hash include is something that we're going to learn about later. For now, I'm going to say we're always going to put this in. It is something for our compiler to actually read another file of code. So C comes with other files that we're going to be using. And don't worry too much about this. What this is doing is giving us access to this thing called the standard input-output library. That allows us to make text appear on this screen when we run our code, and it also gives us the ability to read in information from that screen. Then we've got the main function. I'm using the keyword function here. This is something we're going to learn about later. A function is a part of our code that actually runs line by line. So we will have these brackets here and here, and all of the lines in between are going to run one after the other, and they're going to actually do something. So I'm just going to say do something because there's so many things that they can do, and we'll get into those details as we go along. So I don't want to break down too much about what this function is doing because I want to teach you functions when it is relevant for you to know how to use them. So for the moment, this line here is always going to be the same. And we're just going to use it like that. So I do have some details here about what it is, but again, I'm going to cover that in later lectures. So you can read these details if you want to, but not super important. The important thing is that this line here, this int main void, and these brackets, those brackets contain the code that we're going to run. So what we call that is the body of the function in here. Everything between the curly brackets are a set of instructions that we're going to carry out. Sorry, when I say we, I mean the computer. I'm obviously a human. Just in case you're wondering, robot lecturer beep boop, I am not a robot, but also a human. Did I say also? Oh, I'm just giving it away. Okay, fine, I'm a robot. So between these brackets are things that we're going to ask our computer to do. So we've got this thing here which says printf hello world. This is something that we actually got from the input-output library that's going to make text appear on the screen. This particular line is going to make text appear. I'll talk about this in a second. This is a particular symbol. And this return 0. Return is actually a keyword in C, which is why our gedit here is actually going to give us a whole lot of nice colors to tell us what things are happening. So hash include is a specific color because it's a specific type of command. Return is a specific color because it's a specific keyword in C. So I'm tripping over myself when I'm speaking here. So the return is something that functions will generally do. And this says, I have completed successfully. So this is an old school thing. We won't actually be using this that much, but an old school thing in C is to say, I'm going to give back 0 if nothing went wrong. So 0 means nothing went wrong. Anything other than 0 means something went wrong, and it's like a code for what went wrong. So I don't know if anyone has seen this before, but if I said something like return 404, that would be a code saying that that's actually one of the web codes that says that a web page wasn't found. So you can see that error codes exist out there in the world. We're not going to be using them that much, so I'm going to put that back to return 0. Return 0 says that what was I going to say? Return 0 means that this completed correctly. Okay, so in terms of editing and compilation of these things, let's have a look at using this using DCC to get this code working. So I've opened gedit already to edit the file. DCC, oops, where are we, is a compiler. So we would run this here in this window. So if I do ls again, directory listing, this tells me I've got my one file here. I may have edited, oops, that's not the one I'm looking for. I may have edited that file, so I'm just going to save this first with Control S. If you want to, you can do that, or you can click on that to save. That means this file is now in its current state that I finished editing it there. If I want to compile this, so compile this basically takes the text that I've written there, translates that into a program that will actually run. I will do that with the program DCC. So anytime I'm using a program in my terminal, I will type the name of it first, and then I will say what other information does it need to be able to run. So the first thing it's going to need is it's going to need to know which file I want it to compile. So this is going to translate it, but sometimes I want to, in general actually, I want to make sure that this gives me a particular file back. So I do that with a command called -o. So -o says what is the output of this file, and the output of this file, I'm going to give it a name of the thing that I want it to create. So for the moment, I'm going to call it hello. Often we will call it the same thing as what we've named this file, but I want to show you that I can call it hello, and I'm going to press enter. DCC is now running. And when it's finished, if I do my directory listing here, don't worry too much about this. This is a backup of my text file. But what it's done is it's read this file, and I said, read that file and output this file. So now we have this file here called hello. So it's created a file called hello, which is a translation of the program that's here in a format that my computer can now run. So this command is something that you will probably get to look at a lot more. I will show you more later, and you'll see it in your tutorials. So what this DCC has done is it's taken my program file, which is the stuff I wrote in, and then translated it into this file here, hello, which can now do stuff. So I will run this command. So to run hello, I have to type in a particular bit before that, which is /. Don't worry if all this stuff is going over your head right now. We'll get there over time as we practice these things. So I'm just showing you the first time. If I run this, hello, it types out hello world, which means what it did was it went to where my int main was, and it said, I'm going to run these two lines. The first line prints out hello world with this thing at the end. So this thing is a different color. /n will send basically the enter key to the terminal, which is why this line appears down here and doesn't appear directly after that text. So the /n is something that's, because I can't just, for example, press the enter key here and expect this thing to print out an enter key. I needed a symbol to say press the enter key when you're finished printing out that bit of text. So that is our first little bit of code running there. Let me go back to my slides. Don't worry, I can see in chat there's a lot of people saying this is like I don't know what's going on yet. That's fine. We're going to get through that. And we're going to have a look at this more on Friday, but also in your tutorials and labs this week. Your tutor's going to go through how to do all of this in detail. So that is our first working program. but don't worry, we'll get into it later. Like this is just I just wanted to show you some of the basics of it, but don't worry if you don't get it. We are going to repeat this kind of stuff again and have a look at it. Okay, so I'm going to wrap up our first lecture there. So we've given you a lot of information just about the administration of COMP1511, but we also had a quick look at the history of computers and how they work. So I want to tell you a little bit about what we're going to be doing with the lectures. So we're going to be doing this 2-hour block of the lectures. But what I'm going to do is after the lecture officially finishes, which is now, I will stay back and answer questions. So anyone who doesn't have their tutorial right now, you can stick around, and I'll stick around for a little bit and answer any questions that come up in the chat, probably for the next kind of 15-20 minutes. It really depends on how long people want to hang around and chat. This is the same thing that I would do in person in my lecture theatre, but the official lecture is over now. Tutorials and labs will be happening this week, so your tutors are going to take you through what I just took you through there, but they're going to have a bit more time to go through it with you. So they'll show you how things are happening. You will have examples that you can play around with and stuff like that as well. Okay, I will wrap this up here, but I will come back in like 5 minutes or so and answer questions and things like that. But otherwise, I will see you again on Friday, and hopefully most of you will have your tutorials and your labs by then, and your tutors can take you through a bit of your very first coding of your own. Okay, see you in a second. I just remembered this mic is still on. Alrighty, I'm back. So anyone who wanted to stick around afterwards to ask me questions or anything like that, obviously if you have a tutorial to go to now, you should have gone to the tutorial. This is just if anyone doesn't have the tutorial right now and just wants to talk to me about anything like that. So if you do have any questions, fire away now in chat. I've got some time to hang out. I mean, like, I do have my lunch. I've got a bit of bread here that I'm going to potentially eat during answering our questions, so that's how we go. Okay, Lin Rongkong is saying, I'm not clear about the assessment system of weekly programming test. What is the difference between passes all, fails several, and any attempt? Okay, let's go back to the slide on that. Okay. Oh wait, it's not even in the slide. I know I've got it somewhere. I think it's in the course outline. So basically, there are 3 questions in the weekly test, and the weekly test marking is um, very permissive in a sense, in that you make any attempt at the weekly test, you're still going to get 50% in the weekly test. So to pass the section on weekly tests, all you've got to do is try. Um, if you are not doing that well in the weekly test and you're getting a lot of stuff wrong, you're still going to get 75% of the weekly test. Because the point of the weekly test is to do it, not necessarily to succeed at it. So doing the weekly tests gives you an idea of where you're up to, not necessarily needing to pass all the questions to get all the marks or anything like that. So that's the way the weekly test is set up. It's set up there uh, for you to just sort of do it each week to get an idea of how you're going. So hopefully that helps. So what I'm saying is, like, with the marks there, if you can pass all of the tests, so we're going to test your code to see if it works, then you get full marks. Even if you fail a lot of those tests, so a lot of your code's not really that functional, we'll still give you 75% of the marks. So long as you've tried the weekly test at all, even if things went really badly, but you had a good go at it, you'll still get 50% of the marks. That's how we're marking it. It's very different from how we're marking other things. If you do the assignment and you had a fair crack at it, but nothing worked, you won't get very many marks. So it's much harsher, the marking in the parts of the course where we're assessing you on your capabilities. Whereas the weekly test is we're basically throwing free marks at you to make sure that you do them, because they're valuable for you to be doing. Okay, Akshit Amin is saying, can we use Nano or Vim instead of gedit? Yes, you can. What I'm going to be presenting to everyone is the sort of basic way to do things, the easiest possible way to get things done. But if you want to use other things, especially if you've got experience from outside the course and you want to use different editors and things, they will work. And if you're using our systems here, where are we? Like VLab, we can open other editors here. I wonder if we have Nano. I doubt it. Oh, we do. There you go. We've got Nano. Do we have Vim? We have Vim as well. Oh, I'm going to have to figure out how to exit Vim. How do I get out of Vim? Oh, is it Control Q? I don't use Vim, as you can tell. All right, I'm just gonna back. I'm gonna go back to my slides. But yes, you can use other editors if you need. Oh, I apologize. I can't read your name, whoever was asking that question. But the question was, I did not understand anything about your coding in the last 10 minutes. Don't worry. We've all got to start somewhere. And in those 10 minutes, I just sort of showed some code and showed it running. But I didn't necessarily teach you that much about how it's doing what it's doing or what it's doing. I can probably go through it again in a second, actually. So let me go through some of these questions, and then we'll have another quick look at it. Anivrid Haribabu is asking, are online tutes something that can be watched later as a recording? Yes, most of them will be recorded. You can always check with your tutor, but most all of them will be recorded. If not, at least one a week will be recorded. Emmanuel Ho is asking, with DCC and gedit, are they already installed on VLab? Yes, they are already installed in VLab, so you can just use them. There is a little bit that we will do that you will be doing in your tutorials to set up what's going on here. Let me just... Wait, Shift Q? I love it. I'm just going to ditch the terminal window. So, as you can see, it was Shift ZZ, it wasn't Shift Q. Yeah. As you can see, I don't use Vim. And I know that Vim has a whole bunch of weird stuff going on. I've used a whole bunch of other different editors, but Vim's one where I've always just kind of gone hard enough that I'm not really sure about. Okay, so 1511 setup is a command that we've put into the system that actually sets up a bunch of defaults. So mine doesn't do anything because I've already run it before, but it will also set up some of the things for gedit that allows gedit to work nicely with C. So we will probably all be doing this in our tutes and labs this week to get our setups going. That's if you're using VLab. I would suggest that VLab is a good way to do things. Your tutors and your lab demonstrators, because you've got multiple people in your labs, will help you get all of this kind of stuff set up. So don't worry if you haven't got anything set up yet. Okay, other questions? Josh is asking, do we need to set up Windows services for Linux WSL, or does VLab have pretty much the same functionality? It's up to you, Josh. I would say that VLab is one of the better ways to sort of get started for us, because what it does is it drops you directly into a Linux environment. So you get some experience with the Linux operating system. So I think it's worth getting some experience with the different operating systems, because when you are programming, chances are a lot of different systems only work in certain operating systems. So it's good to get experience with different ones. So if you're comfortable in Windows, this is really funny, right? If you're comfortable in Windows, I would suggest using Linux. If you're comfortable in Linux, I would suggest, oh, why don't you try doing this in Windows? Why don't you try a Visual Studio Code setup with SSH into CSE? So that way, what we're doing is we're trying to get familiarity with as many different systems as we can. Daryl's asking, what sort of things can you do in C that you can't do in other languages? So one of the big things that we will definitely be doing in C is memory management. We will actually be grabbing pieces of memory from our computer and saying, I want to use this memory, and then we're going to put information in it. And then we're going to give that information back to the computer. We're going to be using direct addressing of memory, so we're going to be able to say, at this address, somewhere in this big bank of computer memory, I have stored some information, and I'm going to go back for it later. That kind of thing. So most other programming languages will just say, I have created some information, and I'm going to let the computer handle how to store that information, how to retrieve it. In C, we're going to do it ourselves. So it's a little bit more hands-on. So it's a little bit like, I don't know, some programming languages might be like riding a bicycle. C gets you to build the bicycle, then you ride it. So there's a little bit more depth. That's what we're going to be doing with C. That was Daryl's question there, Daryl Chang's question. Nabonio Saka is asking, can we download Sublime text on the remote computers, or will we be required to use gedit? So we're not necessarily going to be required to use gedit. Shrey's been answering a lot of these questions as well. I'll see if Shrey's already answered that. He said yes. Not sure if you can download Sublime text. I'm not sure. I think that we can actually download and install things here. I tend to use the setup just as it is. But yeah, there will be ways to do it. Also, if you're working largely on your own computer, you will actually be able to use whatever systems that you're using, like Sublime. So there are a lot of options where you can do things yourself if you want to. Chinmay Toshniwal is saying, so after completing the weekly lab assignments and submitting them, we can check our grade using Give. Things will not be marked immediately. Things are marked automatically, but they're not marked immediately. So you will be able to check your submissions using Give, but you will also be able to check your submissions. Go to the 20T3 website. So this is our web CMS. I don't know why it's taking so long to load. It might be taking so long to load because I'm smashing my upload stream by streaming. But even that shouldn't necessarily... Anyway, there is a link on the course website that says view auto test submissions and marking, and you'll be able to view your results there. Not everything's going to be marked immediately because a lot of the stuff is marked a little bit by hand. So it's this link here. When you click on that, you'll be asked to log in. I'm not going to log in because then I'll look at all of your marks, which is that breach of privacy I was talking about before. But here, you'll log in, you'll be able to see your own marks and results. Not everything will be marked the second you hand it in. When you hand it in, the systems will have a quick look at it and suggest to you if there are any problems with your submission, like it's not compiling or something like that, but it won't give you a mark right away. Like, we actually give you the marks. Yongjang Liu is asking, how did you open the window with the black background? That is a terminal. So, when we're set up in VLab, we'll have some options here. This one is a terminal, which allows us to use the command line, which is the way that we would generally be working in Linux. I just press this button here for it. When we're in VLab, we will be using this a fair bit. If you're using other systems, like you're working within Windows at home using VS Code, VS Code has its own terminal, which is part of the development environment that is VS Code. I haven't used it that much recently, so I'm not going to start to necessarily give advice about that. But all the nitty-gritty of this stuff, talk to your tutors and your lab demonstrators this week about this stuff. So one of our goals this week with the smaller classes, the tutes and labs, is just to get everyone up to speed on this stuff. Oh, Shrey's wondering whether I should keep... I'm happy to answer the questions, Shrey, but I'm also happy if you put some text in there as well to help people. Okay. Vanessa is asking, if you're in an in-person lab, do you need to bring a laptop? No, you don't. There are computers that you can use. However, you can if you want to. There's no problem with you bringing a laptop. The tutorial will be in person with no computers. So if you want to take notes on your laptop and stuff in that, you can totally bring it. The lab itself, we have CSE's computers, which are going to look a lot like this one over here. The VLab window is the same as the lab computer. So you can use this, or you can use your own computer. It's actually probably worth bringing your own computer in, at least to the first one, and talking to your tutor about how to get that one set up so that you can work from home as well. Because you're not going to be able to work in the CSE labs that much, only during lab time. So the only people who are getting swipe access to those labs are the people teaching in them. Usually those labs would be always open and you could just walk in any time and use them. But unfortunately, due to pandemic-related restrictions, we don't actually allow people to be in the labs except when they've got a class going. Ruhao Chen is asking about other kinds of VNC viewers to connect to VLab, because Tiger VNC is running really slow. I think that we're going to have problems if Tiger VNC is running really slow. I don't think that other VNC viewers are necessarily going to change that. I'm not sure you're going to get a great option elsewhere. So I think that Ruhao, you might want to have a chat with your tutor about other options, because there might be other ways to connect than that. Okay, going through chat, everyone's helping me to exit from Vim from before. Paco Chung is asking, how do I log in to VLab? Okay, so I think that you probably want to go through the instructions that we have on the course website. Here, under Home Computing, there's some instructions there on how to connect to VLab. Oh, hello, how's it going? Well, here's the reward for staying and asking questions, is that Chicken has come to say hi. So this is Chicken. She didn't come along during the actual lecture, but she just came to say hi then. So she decided to come and make sure that I'm answering everyone's questions correctly. So let me just see if I can take that down a bit further. There you go, she's just sitting on my lap there. Okay, what other questions do we have? Kevin's saying, sorry if this is off topic a bit. Can I explain the dash O related to DCC? No worries, Kevin. I don't think that I would consider anything to really be off topic at the moment because this is just questions afterwards. So any questions you have, and I'm sure other people have these questions as well. So let's go back to my COMP1511 directory here. So if I was going to run DCC, DCC as a program will compile. So compile is a translation of a code file. So my code file here is helloworld.c. If I just run this without the dash O, it will still run. But in my directory now, I get this file called a.out. A.out is just the program. So it's just this thing that runs. So if I've got a.out, it will run the same way as hello. But sometimes I just want this thing to be a nicer name. So what I do is if I want it to be a nicer name, I will run hello world.c and -o there. -o says I would like to specify the name of the output. So it's -o for output, and I want to call it something. I'll call it another file name, so like hello there. And instead of writing to a.out, it will then write to hello, as it has done there. I mean, you can kind of see it already because it's already there. This will make the program called hello instead. Okay, where are the other questions? So Kevin, the -o just says I want to specify the output file. If I don't do the -o, every program I make is going to get called a.out. And if they're all called a.out, then I'm going to forget if I'm working on multiple of them which one is which. I'm going to bring it back up to my face now that you've met chicken. Okay. Dan is saying, can I download VLab to my desktop? VLab is not actually a program that runs on your desktop. It's actually something that gives you access to the computers that are running in CSE. And so it gives you basically a view of the computers running in CSE, which means it's got access to all of our resources here. So it's not something that you necessarily download. You can download a viewer that then connects you to things. Which I think is what Shrey said when he meant yes. Yeah, you can download something that gives you access to VLab, yeah. Carrie is asking, can we use GCC instead of DCC? You can technically, but GCC has a lot of potential issues with it. So DCC is a compiler that we've created that allows us to check really specific things that you're doing with your code and also give you a lot of information about what's happening in your code. GCC is less safe than DCC in that it will let you do things that could break your program later on down the track, but it will sort of trust you to be looking out for those things and dealing with them yourself. So the downside of GCC is it will allow you to do things that are potentially unsafe in your code. So we've made DCC extra safe, so it'll let you know if anything is going weird. The problem with using GCC in the course is you can actually lose marks for things that GCC will allow you to do. So because GCC is not being really vigilant and telling you everything that could go wrong with your code in the way that DCC is, it will potentially allow you to compile and submit code that will then fail marking tests later, because our marking tests will be saying, have you completed things in a very correct way, because we want to give you marks based on the absolute correctness of your code, whereas GCC, it's like, okay, the way that I would describe it is DCC is a seatbelt in a car. You can wear your seatbelt in your car or you can't. So GCC is like driving without a seatbelt. Technically, a lot of the time it's going to be fine. You just drive, and so long as nothing happens, as long as you don't have rapid deceleration or get into an accident, it'll still work. But if you do something that's a little bit weird, DCC will stop you from breaking things, whereas GCC will just slam you against the wheel and hurt you, that kind of thing. So I don't know if that analogy is enough for what you're thinking, but that's why we're using DCC instead of GCC. Once you hit a certain point in your programming and you know all of the potential pitfalls in using GCC, you can use it. It's no big deal. DCC also, every time your program finishes, if it doesn't finish correctly, so if we cut it off automatically or there's an error, it will actually go through your program and let you know what led to that error. It'll give you a lot more information than GCC. GCC might say, segmentation fault, which is just a term that means something went weird somewhere in the memory of the computer. Whereas DCC is going to say, you had this issue with this variable doing this kind of thing. So DCC helps you out a bit more with those things. What other questions do we have? Okay, Adam Coppell is asking, are we going to learn all the coding you did in the last 10 minutes in our Tutes labs? High-key confused right now. Yeah, you are. So your tutors are going to go through all of that from the beginning, and they're going to do the same kind of thing where they sort of deconstruct what each line of code is and what it means. And they've got more time to do it. So, yeah. Bill's asking, DCC uses LLVM as the back, right? Well, Bill, that's a big question. DCC is using, what is it using? It's using GCC. I think it's using Clang. It's using GDB. And it's using Valgrind. So if you don't know what any of those words mean, don't worry. You don't have to know what any of those words mean. But what DCC is doing is it's combining a whole bunch of professional developer tools that do diagnostics on programs, as well as combining multiple different compilers, so that we can basically, we've got this tool, so it automatically does analysis on your code to figure out what's working and what isn't. So as much as using all of those tools at once is a lot slower than using a normal compiler, it's much better for working in situations where we don't necessarily know that everyone knows everything about code already, which is why we combine all these things together to kind of do its own error reporting to you. So that's the benefits of DCC. Lots of little back-end stuff like that. Kevin's asking also about the // to run the code. Yeah, we can look at that. In fact, I can go through some of that stuff already. So if I want to run hello here, it says command not found. So it says that I'm not allowed to run hello, and that's because this hello isn't actually one of our sort of registered programs. But this dot here actually means current directory. That means the directory I'm in right now. So if I say current directory / and look at the / here, this is the same /. So me saying dot is like if I typed in all of this, which is my current directory. And then I do a /, which means I'm looking at the files in the current directory. And then I type in hello. That means I'm navigating to the current directory and typing in hello, which will be found. So the command hello was not something that existed. But this / hello will give us access to the current directory and the file hello, which will then be able to run it. So it's a little bit more detail than I would necessarily talk about, but the / is just how we run a file that is currently in the directory that we're in. Emmanuel's asking if there's a test this week. There is not a test this week. Even the tutorial and lab questions are not marked this week. So this week is just finding your feet. You know, is just give you a chance to just write your first programs and get them going with a lot of assistance from the tutors. And if a lot of stuff isn't working, we're not going to penalize you for it. What you're required to do in a normal week is the lab exercises and the weekly test. Those are the things that will give you marks. When I say required, I mean the things that you're going to get marks for. I would say you should probably, at least watch or take part in a tutorial, ask any questions that you need. If you're not watching the lectures each week, you're going to have a bit of a problem the week after when that content is done in the tutorials and labs as well. So, I mean, I would say do everything, but if you're looking for just the things that need marks, the weekly content is labs and weekly tests. In fact, you could not go to the tutorial lab this week, but I would definitely recommend it, because going this week is like getting everything set up properly. I would recommend going to everything, right? Just because we're not marking marking attendance in anything doesn't mean we're not going to teach you something useful in that time. Dan's asking how I can log in but I can't download it. So I think you probably want to go through, I don't know if Shrey's already answered this with you, setting up VLab. So you set up a program on your computer, which is a way to view our computers, and then you can go into the login like that. Oh, Josh is saying that your VLab terminal is white rather than black. I'd say, Josh, you can change that, but the thing that I would do is run this command in any of the terminals, 1511 setup, and that will probably set up the defaults down here, and then you'll have the same terminal as I do. Oh, there's also another thing that you can run, 1511 colors, and that will set up the colors in the terminal like I have here, so that my different kinds of files are actually different colors. So I think your tutor is going to take you through that this week anyway. Kat said, sorry I missed the answer before, but someone asked a while back about what types of prep we should do before labs and tutes. What do you recommend? I would say make sure that you've watched the lectures that have happened up until that point. I don't think you necessarily have to go through any tut or lab questions beforehand. If you do have the time and you think you know it well enough to start working on it, feel free, but it's not required in any way. So in general, things are done in a sequential order. You watch the lectures, and then next week's tutorial is going to expect that you've seen the lectures. Then what's in the lab is potentially going to use a lot of the things that have been taught in the tutorial and the lectures. So doing the labs the second they release might be okay, but might be quite difficult. So sometimes it's easier to do the labs after your tutorial. So I'd say that's the rough ordering of things. Emmanuel was asking the same question as Kat, so that's cool. Tiffany says, I have 2 labs back to back today. Since the next lecture is on Friday, is it recommended to have lectures before the labs? Not necessary, Tiffany. So when I'm saying lectures before labs, I'm saying next week's labs require this week's lectures. So on Friday, I'm going to be doing a lecture that is after the majority of the tutorials in the course, because the majority of the tutorials are Tuesday, Wednesday, Thursday. No one needs the Friday lecture this week, but next week's tutorials will use what's in the Friday lecture. So don't worry too much if things, if you're worried about this Tuesday lecture needing to be before all of your tutes and labs this week. It so happens that the first thing we do every week is a lecture, because the Tuesday morning is the first class for COMP1511, this lecture, and then everything after that is everything after that is the tutorials and labs. But everything that we're going to be doing in the tutes and labs is going to be covering content from the week before, not from that week's lectures. So you don't have to worry too much about things sort of overlapping like that. The two labs back to back, I assume these are for different subjects. You might want to look into, there are possibilities to move to other labs if it's too much work to do two labs back to back. See how you go though. Even some of the tutors will be okay with you unofficially going to another lab if it's too much to do. Like, I don't know, if it's 6 hours in a row, like I would be a bit leery of trying to concentrate for that long, but up to you, you know. Okay, where are we? All right, so Kevin was saying, yeah, dash O is a name changer. So with compilation, Kevin's asking, do you need to compile at the very end after all your code is written, or do you compile as you go? Um, that's a good, yeah, Shrey's also saying that's a good question. What we usually do is we write small amounts of code so that we get an idea about something and to see if something works, we'll compile it and try to run it. So we'll often run incomplete programs just to make sure things are working. The compiler is not only going to translate your code into a program that can run, it's also going to check that your code is set up in such a way that's going to work. So it's like compiling you could nearly treat as running a spell checker or a grammar checker on your code. So if you treat it like that, it's pretty useful. And so sometimes we will compile code that we know isn't finished, and we'll repeatedly compile code we know isn't finished, just so we can clean up all of those kind of spell check grammar style errors that we're going to have. Bill's asking if there is a GitHub organization for UNSW students. I'm not sure if there is a GitHub organization. I don't know of it, so chances are there isn't one for the whole of UNSW. A lot of individual subjects will have it. We don't in 1511 because we're grappling with the basics here at the moment. So even though we use Git in the background, we won't necessarily be teaching everyone how to interface with it at this point. Oh, Alvin's here, one of the tutors. So we shouldn't wear seatbelts if we're an experienced driver. That's probably an interesting point. So I was talking about the whole idea about GCC being driving without seatbelts, whereas DCC being kind of driving with seatbelts. I probably should have said training wheels. It's more like training wheels on a bicycle, where they're very useful to have if you don't know how to ride yet, but once you know how to ride, you don't really need them. Having said that, the interesting thing about DCC and its kind of really high level error checking and stuff like that is we've had a lot of people who are professional programmers say, can we use this? Because it seems like something that we would want to use for all of our kind of partway through the development process. When you go to production at the end, you might use something like GCC, but in the meantime, you'd want something that has as much error checking as possible, like DCC. So I think it's not even as an experienced driver you stop using it. I think experienced programmers have actually been asking us if they could use it. And Carrie's thanking me for the answer there. I'm 10 minutes behind on chat, I see here now. Oh, Colin's asking about why the results look the same before adding the dash O and after adding the dash O. You want clarification on the files that are being created. Okay, let me show you something. I'm going to remove those two files. So I'm going to, rm is the command for removal, not the leader of BTS. I always love that joke. Okay, so I'm going to remove these two files, rm a.out and rm hello. This is me deleting those two files. If I do directory listing now, you see that those files aren't there. So if I now do a compile of hello world.c, we will see one file has been created, a.out. So I did another listing and I see a.out. That means that if I didn't specify the output file, I get the generic name of an output file, a.out. So let me now delete a.out, and we'll have a look here, and we see, okay, we have no files here. So if I want to now compile, which is to create a new file, but this time I'm going to say I want it to be called hello. I now do a directory listing here to see what I have in this folder. Now this time when it created a file, it didn't create a.out, it created the file with the new name that I suggested here with -o. So that's how the -o works. So hopefully that answers your question, Colin. William's asking for some information about myself, like my experience in CSE and what my thesis and research and stuff are. So I didn't actually say that in the introduction. I didn't want to use up a lot of time in the lecture itself talking about myself, because I figured you want to know about the course. But I actually studied here at CSE around the turn of the century, as it were. And I did a software engineering degree. So I did a thesis in software engineering. My thesis was based on graphics and artificial intelligence. I kind of wanted to get into computer games at that point, and I saw graphics and AI as being a good starting point in how to get into that field. I worked as an artificial intelligence researcher at UNSW for a couple of years after that. Then I went off and did a bunch of other things for a while. I ended up doing a lot of research into VR stuff. So I like to say I did VR before it was cool. So before all the head-mounted displays started appearing again, I was working on things with large-scale projection environments and how we could do interactive systems in like the idea that you'd walk into a room and do stuff. So I did a lot of stuff there. Did a PhD, haven't completed, so that kind of languished for a while. But the PhD that I was working on was distributed algorithms for game playing. So think chess computers, Go playing computers and stuff like that. I was working on those kinds of algorithms to do them over a compute cluster. So I think the biggest I got with that, the funnest thing that I did with that, was having, I think, 2,000 nodes on an Amazon compute cluster. So that's like 2,000 separate CPUs running my game playing algorithms. And I competed in an international competition and did okay. I think I ended up 6th out of about 50 entrants or so. So that was the high point of what I did with my PhD, but then it kind of fizzled near the end, and I ended up leaving the PhD to go teach instead. And I spent a few years teaching people how to make computer games. And that's where I did a lot of learning about how to teach, and then I came back here to CSE to be a lecturer. So that's my kind of journey from my tertiary education and my working career and stuff like that, and then segueing back into teaching to come back here to CSE. So that's been the last, what am I thinking, last 20 years. Okay, so Josh is asking, in VLab, when you open a term, it looks like UX term, which looks a bit different to yours. Did I do something wrong in setup? And the answer that I think both Shrey and I gave is running 1511 setup can change that stuff to help it work better. Well, not better. It's not going to work better, but it just makes it the same as what I'm using, which can give you a nice set of defaults that you can use until you want to start modifying stuff on your own. Josh is asking, do I do this after most lectures? Yes, I will do this after every lecture. I will always come back afterwards and answer people's questions. Although it's getting close to 2 p.m. and I haven't even started eating lunch yet. So maybe I will cut it off at some point, but I do want to make sure that, because you can tell from everyone at the end of that lecture just going, oh, I'm so confused, that lectures are dense and they take time to understand. So I always want to slow down afterwards and answer people's questions. I do the same thing in person. So this is exactly the same thing that I would do after a normal lecture in person, where I would deliver the lecture and I would sit outside the lecture theatre. People would come past and ask questions. So it's the same kind of thing. And I want to make sure that just because we're online doesn't mean I'm going to cut people off from the kind of support that I would normally give people. Oh, Tiffany, you said it's two COMP1511 labs back to back. Oh, you don't have to go to both of them. You can just go to the one you're enrolled in, unless you're really like, go to the one you're enrolled in and then decide if you need another. If you need another, you can always turn up to another. Otherwise, did you enroll in two? It shouldn't be possible to enroll in two. Yeah, as Shrey is talking about there. Yeah. Or maybe the back to back is the tutorial for 1 hour and the lab for 2 hours. I think the others may have already sorted this out. The tutors have jumped on this already. Kevin's got another question. Last question, you promise. It doesn't have to be the last question. I'm happy to answer any questions you have. You made it sound like compiling is almost like running your code to test for errors. Is it the same as testing your code as you go? Well, testing your code as you go requires you to compile. So your code can't run unless you compile. Basically, you have different components, right? So one component is the text file that you edit. That text file can't run on the computer in C. Other languages it can, but in C it can't. The only way you can get your stuff to run is by translating it in the compiler into a program, then running that program. So the compilation, I think if you've done something like Python doesn't have compilation. You just run the Python code itself. So when Python runs, it will read the code and then run it line by line. When C runs, what it will do is it will say, you need to have translated all of this code into stuff that runs and then run it. So Python is like running a compiler in the code, each line at a time, just as it runs. C says, I want the whole thing compiled first and then I run it. So it's just that slightly different way of doing things. Kevin's saying, thank you, no worries, happy to. Emmanuel's trying to send a link, but YouTube is going to block links automatically. We had a lot of people try to sell random links, and so... Oh, there is a GitHub page for UNSW COMP1511? Oh, that might be us. I don't think that's public, though. I'm not sure. Because there is a COMP1511, but if that's ours, that's the one that has all of our content for the course. So it's not something that we would allow people to see because it's got all the solutions to everything. Otherwise, it could just be someone else's. It could just be someone else created a GitHub and they stored their coursework there. If it is just a student who stored their coursework there, I would suggest not looking at it. Because again, that's that kind of thing where you're going to see all the answers there and it's going to ruin your chance of actually figuring those answers out for yourself. So we'll see how that goes. I think Alvin's helping Tiffany out there with the lab and timetable stuff. Yes. 1 hour slot, 2 hour slot. So if it's like that, then it's okay. So it's not 2 labs. It's actually the tutorial lab session altogether. So hopefully that clears that up for you. Kevin's talking about my lunch. Don't worry, it was a sandwich. It's a baguette, so it was never hot to begin with. So I knew that because I ordered it earlier, so I knew it was going to be fine. But then I was like, figuring I thought I'd eat while answering questions, and I forgot that one does not really eat and talk at the same time. It's very difficult to do. Okay. Dan is asking whether gedit and DCC are the same thing. No, they're actually quite different. So, gedit. Oops. Spell that correctly. Gedit is just this part of it. Oops. Too small. Which gives us the ability to edit text. So gedit is just changing what is the contents of this C file here. Someone's come to say hello again. She's investigating my lunch because my lunch looks tasty. um, Tiffany was asking what breed chicken is. Chicken is like a... I think the technical term is domestic short hair, but it's probably just like Sydney mongrel cat. Yes, chicken, you're just a mix of whatever cats randomly hang out around Sydney. So we just adopted her and her sister when they were brand new kittens. Her sister unfortunately passed away last year, so she missed out on the chance to ever be famous like chicken is, unfortunately. Yeah, so gedit is this editor, which gives us the ability to write code. DCC is a program that reads all of this and translates it into something which is then basically a set of instructions that the computer can run. So it's kind of like this is the human readable side of it, and then DCC transforms it into like the raw kind of ones and zeros that just get piped into the computer to make it run. Navanil Saka is saying, hit us with the like and subscribe. I'll see you next time before you sign off. Well, I've reached the end of the questions here, so I will sign off saying that if you want to, you can subscribe, but it is completely unnecessary to subscribe. I am not monetizing the YouTube channel in order to deliver lectures to you. You can not subscribe and you will still get all of the lecture links given to you before each lecture via WebCMS. So we are still official UNSW here. I have not clicked monetize on my YouTube channel because I feel like there is a really awkward ethical dilemma if I was to monetize this channel, so I'm not going to. But yes, you can subscribe if you want to. If you subscribe and I do random social streams that aren't officially part of the course content, so if Dan Mansfield and I do another hangout stream or something like that, I am thinking about doing some other random streams where I will just show other stuff that's going on, or even just talk about other things that CSE or computing studying students might be interested in. Then yeah, you can subscribe for that stuff if you want. It's going to be pretty rare, when I'm busy doing all this stuff. I don't have that much time to do other things. Anyway, I will sign off there. Thank you everyone for coming along. Welcome to COMP1511. Apologies if stuff is like really full on for now. We will see everything that I've done today. We will look at again and we will go through and I'll show you the details about how all this code works and how things get going. All right, see you all soon.